Team number 64, National Taiwan University. Team number 123, the University of Rochester. Team number 60, McGill University. Teams, as you come up, please step up to the trophy, get your picture taken, and then proceed to your workstation and do not touch anything. Team number 121, the University of Michigan at Ann Arbor. Team number 125, the University of Tehran. Team number 11, the Arab Academy for Science and Technology, Cairo. Team number 66, the National Yang Ming Chao Tung University. Team number 57, KTH Royal Institute of Technology. Team number 102, Universidad Panamericana Campus Bonatera. Team 75, Seoul National University. Team number 119, the University of Hong Kong. Team number 83, Suleiman Demirel University. Team number 33, the Faculty of Computer Science, Belgrade. Team number 114, the University of Cambridge. Team number 76, Shahid Beheshti University. Team number 89, our hosts, the University of Asia Pacific. Team number 103, Universidad Simón Bolívar. Team number 38, Hanoi University of Science and Technology. Team number 18, Bina Nusantara University. Team 24, Damascus University. Team number 92, the University of Tokyo. Team number 124, the University of Science, VNU HCM. Team number 55, Keio University. Team number 58, Kyoto University. Team number 100, Universidad Mayor de San Simón. Team number 90, the University of British Columbia. Team 110, Universitas Indonesia. Team number 5, Al-Bath University. Team 72, Purdue University. Team 39, the Higher Institute for Applied Sciences and Technology. Team 49, Izhevsk State Technical University. And last but certainly not least, EAFIT University, team number 26. A big round of applause for all of the teams in the 45th ICPC World Finals Dakar. Once again, welcome to all the teams and congratulations on making it to the ICPC World Finals. My name is John Clevenger. I'm the ICPC Technical Director, and I will be back in a little bit to talk to you about some technical matters. But first, it's my great pleasure to introduce the ICPC Director of World Finals Contest, Dr. Jeff Donahue.
All right. Well, good morning, everybody. Good morning, everybody.
Good morning.
Too early? So welcome to the ICPC World Finals DACA. This is wear your mask all the time except at your workstation.
Is this live?
While you're at your workstation, it's up to you.
It's supposed to be?
Yeah, I think so.
All right, good morning. Good morning. I don't know if we're live or not, but
If we are, this is a test stream where we figure out all of the bugs.
I don't know what's going on stage right now yet. What's happening?
They are announcing the teams that are starting soon and all of the rules for the teams.
What are the rules for the teams? Can you recite them for me?
I can. The teams do not touch anything. Is the main rule. Are we live?
You're live?
I guess we can watch YouTube.
Yeah.
What's up?
We are live.
This is it. All right.
All right.
We should probably mute ourselves and let people listen to the stream.
All right.
So we'll do that here. Is it?
You always must have your shirt on the outside, and if you're gonna have a hoodie or sweater or whatever, you must wear it underneath your shirt until you're to your workstation. Right? So no carrying it, tying it around your waist. Come into the hall 3 tomorrow with all of your stuff on, or when you get up to queue, all of your stuff on with your shirt on top and your badge at the very top. Let's see what else. You may wear passive earplugs if you have them. By passive, I mean like foam or rubber, nothing with any electronics. You may be asked if you're wearing it for it to be inspected by the marshals. you'd have to then take it out of your ears and show the marshals, you know, that you're wearing just like a foam or a rubber earplug. But if you want to wear that, that is perfectly fine, but nothing electronic. The restrooms are here, so the gentleman restroom is on this end, and the ladies' restroom is on the other end. So the gentleman's restroom is kind of hard to see, but it's on the other side of this scoreboard that's down here. So, all right. Well, I am really excited about getting this World Finals started, and to get us ready to go, I would like to welcome back to the stage Dr. John Clevenger. Yay! He's going to come up here and tell you not to touch stuff. Yay!
Okay, we are almost ready to go. A few technical notes to make sure that everybody understands the technical guidelines for the contest. You have we have previously published on the ICPC website the technical notes for the contest and the judging notes for the contest. Those are also on your workstation in printed form. Once we get started, you can pick those up. You need, and they are also on your machine. You can check them on, read them on your machine once we get started. The goal for today is to make sure that you understand how the contest is going to work tomorrow. This is our dress rehearsal, and it's important that you try out the things that you are going to want to do tomorrow. You will be given a set of problems here today to solve, and you should write code to solve those problems. Use the DOM Judge control system to submit your solutions, and then try the other functions. For example, try printing if you think you're going to want a printed copy during the contest. Do not try and print the entire Java API or the C++ reference manual or anything like that. That will be considered disruptive to the contest. But if you need to print a few pages of code listing, that's acceptable. The technical notes give you instructions on how to print. Make sure that you follow those instructions. If you have any questions that you would like answered, you must submit them during this practice contest using the clarification request system in DOM Judge. We will, following this dress rehearsal, we will have the coaches award ceremony, and then immediately following that, we will have the answers to questions session. I want to emphasize that it's an answers to questions, not a question and answer session. If you have a question that you want answered during the answers to questions session, you must submit it using the DOM Judge control system during this practice contest. Regarding your machines, you may move the monitor, you may move the keyboard and mouse, but you may not unplug anything. If you choose to move your workstation and it causes your workstation to stop functioning, we will do the best we can to help you, but we can't guarantee it. You take your own risk if you move your workstation. So be careful if you're going to do that. There is in front of each team on the boundary in front of you a web camera. You may not move that web camera, you may not reposition it, you may not adjust it, and you may not block it. That web camera is the ICPC live view of what's going on your team. It is very important that you do not do anything that would disrupt another team. You may not get into another team's space, you may not hang around another team, you may not reach under your table and pull another team's plug out. Anything like that will be considered grounds for disqualification. You also may not do any networking operations other than what is implied by the use of the contest control system. Do not use your machine to try and ping the judges and see what happens, because what will happen is our technical staff will detect that you did that and they will come and escort you off the contest floor. Do not do anything on the network other than use DomJudge to submit your programs or to print the way the technical notes tell you. Notice that this is different from yesterday. Your machines have been completely re-imaged overnight. There's a fresh image on there. Nothing is left from yesterday. And the internet access that you had yesterday has been disabled. You may not use the internet, nor may you use any electronic devices of your own, as Jeff said. During tomorrow's contest, there will be a separate color balloon for each of the problems that the judges give you to solve. During today's contest, this is a dress rehearsal. You will find a set of problems that we will release you to solve shortly, and you will find duplicate problems in there. The reason for the duplicate is we are testing the system to make sure that everything works. You are welcome to submit code twice, once for problem A and then the second time for problem G or whatever the duplicate is, but you won't get a balloon for all of those. We are testing the balloon system, and you will get up to 3 balloons for problems that you solve today, and that's it. So don't come ask us, where's my 7th, 8th, 9th balloon, because I submitted the same code for 7 or 8 or 9 problems. You're not going to get more than 3 balloons today. Tomorrow you will get 1 different colored balloon for each problem that you solve. For spectators, once the contest starts, this is true for both today and tomorrow, there will be hard copies of the problem set available up in the balcony as soon as we start. Tomorrow, the problem set will also be posted online after the contest starts. As is typical in ICPC contests, the scoreboard will be frozen near the end of the contest. For today's contest, the scoreboard will freeze 30 minutes from the end of the contest. Tomorrow, the scoreboard will freeze 60 minutes from the end of the contest, and any submissions after that will be reflected simply as pending on the scoreboard. Okay, in just a moment, we're going to start the countdown clock again, and when the clock reaches 0, you will then be allowed to touch all the stuff on your workstation. So Jeff, I think we're ready to go. I'd like to invite Jeff.
All right, one last announcement. This one's super important. You must be in your hotel lobby a little earlier than it says on the sign, to make sure that you get on the bus that's coming here tomorrow. If you don't show up to the lobby on time, the bus will leave without you. If it leaves without you, you won't be here with your team to start the World Finals. So it's really, really, really important that you get to your hotel lobby, shoot for 5 to 10 minutes early so that you make sure that you make the bus. So if you miss the bus, you're going to delay your ability to participate in the World Finals. So make sure you are all show up for the bus. I know it's early in the morning, but we need to get you over here on time so that we can start on time.
Dr. Poucher, Dr. William B. Poucher, to the stage, please. Paging Dr. Poucher. He's got his hat on, he's got his mask on. I think we're ready to go. All right. I think we are ready to start the contest. But there's 5 minutes left on the clock. Do we really want to wait 5 more minutes? I think, are we ready to go? I think we need another ICPC time warp. And the contest countdown will start now. When the clock hits 0, you may reach under your keyboard, take the envelope, and open the problems. All right, spectators and contestants, let's count down to the start of the World Finals dress rehearsal. It starts in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and we're off.
And the contest has just started. Good morning, everyone.
Good morning.
We have Andrew Key here, and this is going to be a terrific practice dress rehearsal for the ICPC World Finals DACA.
Indeed, it will be. We can already see some teams are, in fact, actually teams are opening their packets. Yeah, what a great day in DACA.
It sure is. I think teams are looking through all these practice problems. If you didn't hear earlier, teams have 2 copies of each problem, and they only get balloons for the first copy of the problems, but there are extra copies just to test things.
Right. They want to pad out the full length of the problem set just to make sure that their system works with, the right number of problems.
And it looks like we just got a submission here. I thought I saw one fly up the scoreboard. We will have a scoreboard view in a bit. Here we go. Looks like it's showing up here.
Our University of Warsaw submitted at 0 minutes. 0 minute solves are always great, but unfortunately it looks like it is not a 0 minute solve. Oh!
Looks like we got lots of submits.
Looks like Warsaw was actually on top. They managed to submit to every single problem in the first minute. Is that what happened?
Yeah, it looks like they're flying through things.
I think my best guess is they just submitted an empty file to every single problem.
And just the command line.
Just testing, testing their submissions.
Looks like we are covering this top one a bit.
Yeah, maybe we should. Adjust ourselves a little bit.
Anyway, you Warsaw here with the dark red, the first wrong answer in contest. Lots of teams are, of course, going for the dark green, which is the first correct answer in contest.
Right.
Also called the first blood.
Do you know if there are any prizes for the first correct answer of this contest?
Well, certainly there's at least a balloon, which you get with every correct answer. I don't think it will be a gold one, but we'll see. I don't know anything for certain. In this contest, teams are allowed to use 1 computer, although they have 3 people. This is a little bit different from last World Finals, where there were 3 computers.
Right. Last World Finals, because it was during the pandemic, they didn't want teams sitting so close to each other, or having to necessarily be at the same table, within a couple feet of each other to use the same computer.
Yeah.
So instead, they changed the rules just this one time to make it just each contestant gets their own computer.
I was actually competing in it, and they had these plastic dividers between your teammates.
Were you able to talk with each other even?
You could kind of just back up a bit. But I think most of the time it was somewhat useful.
Right.
And there was certainly passing papers between to pass notes and solution ideas and stuff.
Right. This year has kind of been a return to the normal format.
Yeah, it's very, very traditional.
Where you have 3 chairs right next to each other, and teams are able to, mingle and, swap seats if they want, and they're able to pass notes, and, they're able to work directly together.
It brings back an important part of the contest, which is the collaboration aspect. And that's one of the things that I think ICPC, collaboration working off terminal, is one of the things that makes this rule set different from a lot of the other ones like Hacker Cup, Code Jam, Code Forces.
Right. The team aspect is really emphasized by the fact that you actually have to share the computer, right?
Yeah, it's not just like you times 3. It's there's a and we want to work together, help debug code, stuff like that.
So it looks like we have just been delivered a copy of the problems.
We got them. The first one, I've seen this before. This is the problem catering.
Where have you seen this before?
Well, in my time, I did lots of training for World Finals problem sets. And I know this is a previous World Finals problem. And I won't spoil the solution for you, Andrew, because I'm sure as soon as you read the text, you'll see it. But, yeah, it's a pretty tricky problem, I think.
All right. Well, I will take a quick look. Tell him that it's already on. Not us. Cool. So this problem, do you remember which World Finals this is from?
I know it's one before Porto.
Because
Porto was the first one I participated in, so I know it's an older one.
Right.
I don't remember exactly which year though.
Right.
Maybe it may have been the year tourists skipped with the bunch of geometry problems.
Okay.
I don't remember what that was, but that's just like a hunch. There's a very good chance it was a different year instead.
All right. Well, one interesting game that we can play, because these problems don't really matter, and you guys can always look up the solution.
We can look it up, yeah.
One interesting game we can try and play is I don't think I know this problem, so I can try and guess what the problem is from just the samples.
From the samples, all right, that would be pretty cool.
I'm going to read the input format at least. So the input consists of 2 integers, n and k, which are the number of requests and number of catering teams. Then there are a bunch of lines, each containing n minus I plus 1 integers. And it's the cost of moving equipment from location I to I plus j, company in location I, and the n requests are at locations 2 to n plus 2. Minimum moving cost of service all requests. So the first sample looks like it costs 40 to move from 1 to 3, or 0 to 3. And then 30 from 40 from 0 to 1, 30 from 0 to 2, and 40 from 0 to 3.
Yeah,
is that the right interpretation of this problem?
I can tell you this is a difficult problem. This is not going to be the one that's dark green. Don't tell you that.
Okay. All right.
This involves some hack pack, and this would take even a good team over 10 minutes to type.
Okay.
So
I probably would not be able to guess the outcome.
Yeah,
guess how this problem works.
I also remember like the time that I implemented it, I had to look several times at the input just to make sure I was understanding it right.
Right.
Maybe let's look at the next one, which I think is much more reasonable. This one is from Beijing, China, which you participated in, right? Or no?
I did
one of your
not.
Teammates.
That was one of my teammates.
Is that Kevin?
That was Kevin. Yeah.
Kevin. Okay.
Yeah. Kevin participated in that year. That was 2018. Is that right?
Yeah, it would have been 2018.
Right.
In Beijing.
And it's called Comma Sprinkler, right? And it is about English, which is, as we know, one of the most self-consistent and rule-based languages, right?
It is. Also, you gotta. This mic is like.
Mic, so
you gotta. When you turn your head, it kind of loses the audio.
All right. I'll try and stay a little closer to it. So we are trying to insert commas into this sentence, right? Given a sentence, what do we want to do? In every 2 words.
So just to answer some quick questions we see in chat here, there will not be, as far as I know, a Caddis online mirror because this year we are using Dom Judge instead of Caddis.
Right. I don't. Do you know if the problems will be released? I actually don't know. They probably will be released, but I'm not sure if there will be a live mirror running.
I hope we'll be able to show you some of the problem statements, but I'm not sure if you'll be able to see the problem statements yourself or if you'll have to screen grab from the live stream. But I guess we'll see.
You can always take a quick look at steal some ideas from the teams as they're reading the problems.
Yeah.
But I'm not sure if the
when you turn your head toward me, it was the audio.
Yeah, I'm not sure if there will be a direct. If there will be a direct mirror.
Yeah.
Yeah, we'll have to see.
So comma sprinkler is it's not too crazy difficult. It was one of the earlier problems in Beijing, earlier solved problems in Beijing, if I remember correctly.
So what it's saying is that we're trying to add a lot of commas. I don't really understand why that would. Oh, okay, we're just sprinkling, right? And it's the main rules are if there's a word that's preceded by a comma, then we have to find all occurrences of the word and put a comma before every single occurrence, right? And if there's a word anywhere that's followed by a comma, then we have to make sure that word is always followed by a comma everywhere in the sentence, right?
Indeed. So largely you have to like see if there's like some word followed by a comma. You want to like add some additional commas, but doing that, like if you have like the word the after the one instance of the word the, there's a comma. You have to add a comma after all of the words the.
Right.
But also, when you add those commas, you'll add commas before the words that come after the. So if it's like the fox, you add a comma before the fox, and that might cause cascading.
Right, because now you have to add a comma before every instance of fox.
Exactly. Yeah.
Right. And so that might cause a whole set of cascades. Right. And there are also some edge cases that, commas obviously can't overlap with periods, and there might be some periods already in the sentence, right?
Yeah, it's pretty messy. So yeah, you don't want to insert a comma before the first word. I guess that every last word will be followed by a period. If a word comes before, if there's a period before a word, you don't want to add a comma there.
Right.
So you got to be careful with your implementation. But the overall strategy of the problem, I think, isn't too difficult.
Right. So the main strategy is probably just let's just add commas.
And hang on, as we're talking here, University TUM gets the dark green of the contest.
They get the star next to their submission. I think that means that they are the first solve of the entire contest, right?
Of all of them, yeah. First AC. So well done.
Well done. Yeah, it's been honestly, I'm a little surprised. It's been 10 minutes and the first solve only comes in now. What do you think what do you think the teams might be doing?
Well, I think there were certainly people who looked at A and spent some time reading it and are like, oh, this is tough.
Right.
But at the same time, yeah, I guess, so maybe this is problem B that we're reading here, comma sprinkler.
Right.
But they got problem D, AC.
Right.
So maybe we'll at least name what problem D is for the people at home.
Right. Problem D is called landscape generator. This was also a past World Finals problem. Is that right?
So yeah, for context, if you're trying to find the problems, we don't have a link to the problem set, and I don't think there's been one posted in the comments. But if you look up ICPC World Finals, comma sprinkler, you'll probably find it. And then ICPC World Finals, what is this? Landscape generator?
This is landscape generator. And one interesting thing is that teams don't seem to be competing that hard for the scoreboard, because we've seen a correct submission on D, but there actually is a duplicate of D in the whole contest set, right?
Yeah, if you're trying to get the most points possible and you get problem D, there's definitely another problem that you can solve. You just have to like look through the rest of the set and see that they're the same.
Right. It's possible that the scoreboard view we're looking at is filtering those out. But I am a little surprised that we haven't seen like an insta solve on I once someone solved D.
I would expect it for at least one, especially if you get the dark green.
Right.
You might as well. I'll stop trying to make dark green happen. I've said it too much already.
Yeah.
Guys, upvote Monaghan. He is here. Monaghan is from Purdue. I don't know if he just flashed on the camera or he's still there. I guess, we're changing scenes quite quickly.
Right. Panning across all the teams. How many teams are there this year? Do you know?
Oh my goodness, I actually haven't. That's going to be one of the fun facts I learned for tomorrow. I won't spoil it here. We'll pretend I know.
All right, yeah. Well, apparently there are over 130 teams in the dress rehearsal.
Over 130?
They just totally sniped me. I was going to say the number, but I'm actually not sure. I believe there were 136 teams registered, and I think maybe one or two weren't able to make it at the end. But there should be over 130 teams scattered through this whole contest hall.
It's a big contest hall, and one of the things people don't realize, I guess we probably won't talk about this too much in contest, so we're not going to spoil a lot, but this entire contest hall, this isn't like a library or like a computer lab where there are all these computers. This is like a big empty box of a building as of 4 days ago. This entire thing, people just like built and set up and brought all this stuff here, which is an astounding amount of work. Right.
Setting up all these computers is so much work. Every single computer needs to be wired up. All the peripherals for every computer need to be assembled and then hooked up together. And it really just takes a lot of volunteer work to get this all done.
There are teams of volunteers. Bangladesh has been incredibly helpful. The host university is University of Asia Pacific, right?
That's right. That's right.
And yeah, I've met lots of very kind people from there
Right.
over the past few days.
Yeah. Yeah. I believe they're a little bit out from here, right? They're maybe
they're a bit away. They're not like next door. But...
Right. But they are the host university this year, and yeah, we can see in the ticker that they are confirming that the problems are repeated. Because this is just a dress rehearsal, it's not important that the problems are all unique or even novel or new, right?
Yeah.
And in fact, these problems are all, I believe they're all past World Finals problems. I believe they're all past World Finals problems, and there are 2 copies of each problem.
I think long ago they used to actually make a unique problem set for the dress rehearsal. I think this was like several years ago, like a decade ago.
Right.
And then they stopped because it was obviously a lot of work.
Right.
Creating problems is a ton of effort. Oh my goodness, lots of ACs here.
Oh my.
Whoa, we got an AC from National Taiwan University on C.
Right.
And Cambridge got both E and J, which are the same problem, right?
The same problem.
Yes.
But it's what's important is that they managed to pick up both of them. So they've managed to pick up the first solve on both of them. And I believe during the actual contest, the first solve on each problem is its own prize, right?
I know it used to be. Is there still a cash prize for getting first solve?
You know, I realize that I don't know anymore, but I kind of assumed it still was.
So what was it in the past?
I think in the past it was $1,000 per first solve.
So if you got 4 of them, that's $4,000 in your pocket.
Right. Yeah. For the team.
A lot. Yeah.
It's a good prize, and obviously it doesn't apply during the practice day, right? It's just for the actual contest, where one interesting thing about first solves is if you get one, then you probably miss the opportunity to start on. If you get like one easy problem first solve, then you lose the opportunity to work on the other easy problems first, right?
Yeah.
And so you typically don't manage to rack up that many first solves,
unless you're just like incredibly good.
Unless you're incredibly
just solving all the problems first chance you get anyway.
All right. See, TUM, who was the global first solve of the contest, right, has just solved I. Which,
I wonder if the solve on J from Cambridge, the 2 problems instantly, clued them to the fact there's a second copy of each problem.
Right. Maybe they were actually looking at the scoreboard and realized, hey, it doesn't make that much sense for Cambridge to submit 2 problems so close together, right?
Looks like we also got an AC from Jagiellonian University on problem E. They have quite a fun name.
Right.
I gotta say.
Do you know where they're from?
I want to say Jordan, but I could be totally wrong.
Okay. All right. We'll have to look that up another time.
I know UCF made friends with them, with some of the teams there. In particular, Jacob Magnuson. He went to a training camp, and this was a couple of years ago.
Right.
But it was on a different team, not the team that's competing here, I believe. But
right.
They met them and they had fun with a previous team from that university.
Right.
And we were talking about how fun their university name was to say.
Right. Yeah, so we can see that I believe balloons are starting to get handed out, right? I can see a few balloons in the crowd. There's like red balloons and black balloons. Can you tell me a little bit about what the balloons are?
It looks like we got 99 red balloons in storage, and the rest are coming out here. I'm sorry, I couldn't help myself. So, if you solve a problem, either in the practice contest or the real one, you'll get a balloon delivered to your team's workstation. And if you look on the sides of the metal, I think there's a little place where the volunteers can tie the balloons.
Right.
And you get 1 balloon per problem you solve. Even better, if you solve a problem first, instead of a normal latex balloon, you get an aluminum balloon.
Right. It's all shiny, and it's very intimidating to have,
There's a lot of, you're like better than everyone else in some sense.
The balloons really are an interesting concept in that, you can look at the scoreboard, but you can also just look around the room and just see, what balloons there are floating around. And you can see if one team has, just a whole lot of balloons. It is a little scary, One
of the things that I think isn't conveyed super well by this camera angle, although it is quite beautiful and you got the slow pans and everything, is that all of these contest stations are the same height, and they're a little bit taller than people's heads usually when they sit down.
Right.
So when you stand up, everything is like totally level.
Right.
And since balloons are like 6 feet higher, they really stand out.
Right.
You can really look around and you see all these balloons. And it looks like maybe the volunteers are a little behind because I see fewer balloons than I would expect from how many greens there are on the scoreboard.
Right. At this point in the scoreboard, it looks like D is probably the easiest problem. Swarthmore just got the first solve on problem B, which is the comma sprinkling problem we were talking about earlier.
I know Jay is a fiend for implementing things quickly. Jay is geothermal on Code Forces. He is an LGM as of recently. He got it on Code Forces, and he's been very proud of that. And I think he paused doing contests officially. Didn't want to lose the black letter. But I'm sure he'll start up again soon enough. Right.
I mean, at the very least, he's probably done some practice for this, even if
I'm
not
sure.
officially. Right.
He's done tons, I bet.
Right. So, yeah. But yeah, we're really starting to see the ACs come in. We're also seeing plenty of wrong answers. One interesting thing about the practice contest is the wrong answers are maybe almost a good thing.
Yeah, I mean, there are definitely things that you want to test when you are given a new system when you haven't competed in before. And since teams are only allowed 2 years in World Finals, there's a good chance many of them have never been in a World Finals before and want to see what it's like and what different types of codes crash, give you runtime error versus wrong answer versus TLE.
Right.
What sort of things will pass, and then if you touch some memory that technically you don't own, if you're definitely gonna get penalized for that, or if it might be all right.
Right. You can also test things like, exactly how tight is the time limit, like these contestants, these judge machines, I believe are new machines for this contest. And so contestants might not know exactly how long, how much they can run in 1 second on these machines. And so that's another thing that they might be testing by, trying to submit some slow code and just tweaking it a little bit to see exactly how fast it runs.
So I have a question for you, Andrew. This is a great question from chat. We do have chat open, at least for today. So if you have good questions, you can throw them there. Would you say we are unbiased or biased here? What do you think?
I would never publicly admit to being biased.
Well, I will. I am biased. If I've got some people who I don't know. They're popular on Code Forces. It would be great to see Monogon Dark Green a problem, wouldn't it? If there's a circle-based geometry problem, wouldn't it be great to see Monogon get it?
That would be pretty great.
It would be fun.
Yeah, then he can set his profile picture as the circle from the diagram.
And then he can put a little red dot in the right side of it.
Right.
For memes.
Right. Yeah, I mean, obviously, I'm rooting a bit for MIT. I think, but there are a lot of top contestants here this year. And I think it will be really exciting to see how it shakes out.
Oh, for sure, yeah. There are lots of great teams, and there are some teams that it's fun to watch because you know them, but it's great to see everyone as well. All right, so it looks like we got lots of ACs on problem D. Do we want to take a look at what that problem is and read it for the people watching, see how easy of a problem it really is?
Yeah, let's take a look. So the problem D is a landscape generator.
For context, Andrew has seen this problem before, and although I've practiced on many World Finals problems, I don't think I have done this problem.
I don't remember this problem, actually. It doesn't look super familiar,
but never mind.
I assume it must be a World Finals problem. So, the problem is that we have we're starting.
Oh wait, hang on a minute. It says the Interactive Creative Players Collective. And as of last year, interactive problems are officially as of last year, interactive problems are a thing. They exist.
Right.
So this might be an interactive problem.
Can you tell me what an interactive problem is?
That is a great question. I've been doing programming for too long. I just assume everyone in the world knows. So So for most of these programming problems, the way the input and output work, what you have to do is you write a computer program. And it'll read some predefined input, run that input on the code that you wrote, and then your code will print some output. And then the judges see if that output is right, usually with a program of their own. Now, that's what happened for the vast majority of ICPC history. But there's an additional type of problem, which is kind of different and offers some unique possible things that you can do with the problem setting. And that is, instead of having a fixed input, you have an input that's determined by some problem or some program the judges write, and the judges program can set different input depending on what your code outputs. So maybe the judges have a hidden number in mind, and it's your job to guess what number the judges are thinking of. So you can make a guess, and the judges will tell you whether you're too high or too low. And you want to guess, maybe the judges have 100 different numbers, and in only 10 guesses, you want to figure out what the judge's number is.
Right. Yeah, the simplest example of one common example of interactive problems is these like guessing games or things like that, where you're trying to play a game against the judge, right? And it allows for this whole new set of problems where instead of just being able to process some data, you're actually forced to make sure that you can play this game in all situations correctly, right?
Yeah. All right, let's take a look at this one. I may have just jumped the gun. What exactly is this problem here, Andrew? Do you want to read it for us?
Yeah. So Landscape Generator. It's about the Interactive Creative Players Collective, which has the abbreviation ICPC for some reason.
A classic.
And they're working on a new computer game, and they're trying to make it. It's inspired by geological processes. So we're looking at a landscape. It's initially flat, and we can keep lifting it. We can lift or lower little blocks of it, forming horsts, lifted blocks, or grabens, lowered blocks. And we randomly select blocks to raise and lower. That's a pretty interesting thing.
Yeah, if this is like randomly, uniformly chosen at random, that might tell us some interesting things about what kind of landscape we might have, because if it's randomly chosen, and it's randomly chosen whether it's an increase in height or decrease in height, it might be true that on average you don't get very tall mountains or very deep valleys.
Right, and that sometimes actually allows you to that sometimes allows you to have better algorithms that don't necessarily work in the worst case, but work perfectly fine on random data, which is actually often very useful in the real world, right?
Let's keep reading the problem and see if that's something we actually need. But
yeah, so so we are given a sequence of modifications, and the landscape is a sequence of heights, and the operations are of the form R for raise, so increase the height of all points between x1 and x2 by 1. D for depress, which decreases the height of all points between x1 and x2. So these operations all are given two parameters. They're given a lower bound x1 and an upper bound x2, and we'd actually like to modify this entire range at a single time. So the operations we can do are we can raise everything in that range by 1, decrease everything in that range by 1. We can add a linearly shaped hill between x1 and x2, and add a new linearly shaped valley between x1 and x2. The hill and valley operations seem pretty interesting.
So is a hill just like, I guess a hill would be like an upside down V, and a valley would be a normal V?
Yeah, I'm not entirely sure. So what they're saying now...
I guess let's, so we've got these operations. What is it that we're looking for?
I believe what we're looking for is output n lines, where the ith line contains the height at point I after applying all modifications in the given order. So this is actually not an interactive problem.
Okay, yeah.
We're actually just given a sequence of modifications, and we just want to output the final result of all modifications.
That makes sense, yeah. So I guess before we talk about the solution here, one thing we should mention, it looks like we have gotten dark greens from all of the problems. So every problem has been solved as of right now, and we'll see some interesting stats provided by our analytics team on the screen as we talk. So you can take a look at those if you'd like. Right.
We can see, which teams are, Warsaw, we saw did submit every single problem, and now they might have actually started working on the problems for real.
Yeah, it looks like some of our webcams are still a work in progress. This is the test stream after all, so we're working on all the technical difficulties here.
Yeah. Okay, yeah, so this is what a hill means. The way they describe it is a little bit strange, but adding a hill means it means the two endpoints don't get increased, and then the points that are 1 inside get each increased by 1, and then the points that are 2 inside each get increased by 2, and then the next points get increased by 3. Or actually, yeah,
they get increased by 2 or set to the thing plus 1 plus 2.
They get increased by 2. It looks like it is just an increase and not like it's not a equals operations, it's a plus equals operation.
So it's like a plus 0, plus 1, plus 2, plus 3, plus 4, up until you get to the middle.
The midpoint.
And then you start decreasing, I guess.
Right.
Back to 0.
Right. And so we just need to apply all of these operations. Yeah, and so do we? Do you have any thoughts on how to solve this problem?
So yeah, I guess a common idea
Mm-hmm.
is when you need to do some of these like +1, +2, +3 operations.
Right.
You can store a multiplier. You can
Mhm.
imagine instead of doing that, you have like a +1, +2, +3 from the beginning of the array, rather than from like somewhere starting off in the middle. And then you can have a second array, which is like a multiplier of that at each prefix.
Right.
So you can do kind of like a prefix sum of that. You can say like use the beginning of this array, but
Yeah.
use it for this like this to the end.
Right. Right.
And when you do something like that, you can do a positive amount for starting at some particular position, and then a negative amount starting at a different position.
Right.
And that can let you
Right.
adjust the starting point.
Right, right. One interesting way of thinking about this is that if we're trying to increase the height of, increase the height between x1 and x2, we can increase the height from x1 to the end of the list, and then decrease the same amount from x2 to the end of the list. And that leaves only the range between x1 and x2 increased.
So on one hand, you can store like the direct change in height between two,
Right,
and you can also store the change in slope between adjacent elements.
right, right.
And the second operation, this hill and valley operation, these
Right.
are just range change slope by 1. So it's increase the slope by 1 here,
Right.
and then decrease the slope by 1 here.
Right, right, yeah. And so those, this is actually not a super easy problem to solve. It actually is, 10 minutes is a pretty good time to solve this problem, I think.
Well, it's it's a bit tricky. I mean, there's certainly a lot to read, and
There's
then on top of
certainly
that,
a lot to read.
it's a decent amount of code. But
Yeah.
I don't think it's too bad. So one of the things you can do is you can handle each of these three things separately, and you can add them up at the end.
Right. That's one thing which is interesting, right? Because this problem only asks us to output the final result after all operations are done, right? We can actually notice that these operations, you can do them in any order, right? If I raise it by 1 first, and then I decrease it by 1, versus if I decrease it by 1 and then raise it by 1, because it's just addition, right? It doesn't actually matter what order you do it. So you can actually handle them in any order.
Yeah. It looks
then
like
add them
we've got an AC on problem C by NTU.
Right.
It looks like they were very close before. They were just checking if something was equal to 1, but they were missing the 0 case.
Right.
Good at 0 rows.
Right. And it looks like that was their AC submission, right? So they actually did fix it.
Yeah, they caught the 0 case, and looks like they got it now.
Right. So look out for more of that. We have an analytics team in the background who is looking specifically through everyone's code, looking for opportunities to see, looking for what bugs they might have made, right?
And not to spoil too much, but people on this analytics team include Eric Doe
Right.
and some other friends, which
Right.
you may be familiar with. They will be appearing on stream
Right.
tomorrow. So
Right.
be sure you stay tuned for that.
Yeah. So it's a pretty tricky job that they have trying to understand people's bugs. Like the teams are doing this at the same time as them, right? They're trying to the teams are trying to debug just as fast as the analytics team, and we'll see how often the analytics team manages to catch the bug before the teams.
There's probably like a ton of data that they've got flow into them, and they gotta figure out how to find what would be interesting.
Right.
I'm sure they're probably just looking through random submissions and be like, oh, that was silly. They were so close.
Right.
They're only getting one test case wrong.
Yeah. It's a tough job.
Yeah. I remember one of the times when I was judging some contests, there were these teams, and unfortunately, they weren't quite World Finals caliber teams,
Right.
but they were starting off, and it was great to see them do the contest. And they solved 2 of the easier problems in our set.
Right.
But then they got pretty stuck on the third one. It required, I think, 2D arrays,
Right.
and that was a little above what they had learned.
Right.
So they wrote us a poem in a comment and submitted it.
Right.
And as judges, we were like, why did you guys submit this code? When we first saw it, it didn't even pass samples. And then we looked at their source code, and it warmed our hearts a little bit to see the poem about their attempt at this problem, and
Yeah.
that they had put effort into it and kept trying.
They kept going.
Even though they knew this was all they could do in the contest. So
We'll see if we receive any heartwarming poems this World Finals.
if we do, be sure to call them out, and we'll take a look and read them to you guys.
Yeah. Hopefully these teams will be will be working hard trying to earn their placing. You know.
I expect this will be taken a bit more seriously,
Right.
because you only get 2 shots at World Finals. This is one of them here.
Right.
So I imagine a lot of the diffs will be something like this. The teams will have forgotten that they have some debug output,
Right.
and somewhere else they've gotten off by 1 case.
Right. Yeah, these forgetting debug output is definitely a bug that you really should it's pretty tragic when it happens, you know,
Yeah.
because you run your code, it's doing everything correctly, and you kind of just glance over or skim over the debug output that maybe only sometimes prints out, and it's pretty tragic when you waste 20 penalty on a submit that's only rolled by debug output.
Yeah, especially in cases like the most common time I'll do this, and I was like bonk myself in the face when I make the mistake. But the common issue I make is if there are like 2 different types of cases. There's
Right.
like one where n is even, and there's a different set of code where n is odd.
Right.
And then you pass the n is even case, and then you're trying the n is odd case, and there's some issues. And then at the end you fix it, and you check the n is odd case. There's no debug output, and you submit, but you forgot to run the other sample where n was even.
Right.
And then you still have debug output there.
Right.
It's like, oops, I'm silly.
Yeah. One thing I'm always in the habit of using CERR when I use debug output, so standard error, which is not judged, right? But that has its own host of problems, because if you print too much out of that, instead of getting wrong answer, you still will just get time limit exceeded.
Yeah.
And so at the end of the day, there's no fixing it. You just have to disable it.
Just got to be careful.
Yeah.
Look over your code after you submit.
Yeah, I mean, it really is worth it. Like spending 1 extra minute, or it doesn't even take an extra minute, but spending 30 seconds checking your code is definitely worth it to prevent these silly 20-minute penalties.
I suspect for some of these teams, they're interested in just getting the dark green for the dress rehearsal, so they were just submitting even without running samples.
Right. Yeah.
And that's always a possibility here.
Right. Yeah. Do you know if the judging system runs samples for you?
Well, I know if you get samples wrong, I'm pretty sure it counts as a wrong answer.
If you get samples wrong, it does count as a wrong answer.
I believe so.
I see. Yeah. There's some judges where it doesn't count, but I think ICPC judges it typically does count, right?
Yeah, Code Forces is a bit nice in that respect, where if you get the first sample wrong, yeah. If you get the first sample wrong, then you don't get penalized for it.
Yeah. Did we have doubled audio? Maybe someone in chat can tell us if you heard any doubled audio or anything like that.
Yeah, how's the audio sounding? I guess that's the open question. Good thing for us to test here.
Yeah. Oh, this is a classic mistake. Beijing Xiaotong fixes integer overflow on problem D.
Oh no.
Yeah, it's always kind of this is problem D, right? Yeah, it's always kind of tricky, because a lot of the time when you read the problem, the size of the inputs is actually not too big, so maybe all numbers in the input are only up to 10,000 or 100,000, right? And numbers up to 100,000 fit comfortably inside normal ints, yeah? But sometimes the problem requires actually adding a lot of them together. And if you're not careful, you might forget that if you add together 100,000 numbers of 100,000, it's barely above 2 billion, the maximum for a normal int. And so it's really easy to forget that kind of integer overflow.
As an example, in this case, you could have a hill, and the hill will add +1, +2, +3, +4, +5. Each of those numbers are pretty small. Even if the array has 1,000,000 big, you're only adding up to +1,000,000. Those are all ints.
Right.
But if you do this a bunch of times,
Right.
how many times can you do it?
Well, we can actually do it
200,000?
At most 200,000 times.
Yeah, if you 200,000 times 1,000,000, that's obviously over 10 to the 9th. So
Right.
it'll overflow ints.
Right. Yeah. So it's definitely it's definitely like a common bug that's kind of especially hard to catch, because it's not just the numbers are big in input. You actually it actually depends on the there was a bit of it. I think we accidentally had the mic from the streaming camera as well.
Ah,
So
yeah,
we
that would
turned
do
it off
something.
now. Yeah. But cool. Yeah, we're just trying to make sure that we clear through our queue of technical problems that might have happened before the actual contest. Just like teams are, we are also just making sure that this is a rehearsal for us as well.
We're testing both the judging systems and the streaming systems today.
Right, right. Yeah. So here we can see Warsaw testing policy-based data structures.
We also, real quick, we also have a fun fact from the analytics team,
Yep,
which is that the analytics team consists of 7 people.
indeed it does.
I
Can
bet
you list all
only
7?
the analytics team would know that. Oh, I can list. No, I can list 2.
We'll have to make sure we list.
Do you know all 7?
I think
I know Eric Doe, I know Nick,
yeah.
and that's
There's
kind of
the head of analytics this year is Yakov.
Oh, okay.
I can't pronounce the last name.
All right.
There's Misov, who's well known as a top coder problem setter, and there is I don't know the rest of the team. So I've got only
7 wonders of the world. Can you name all the wonders of the world, Andrew?
7 wonders of the world. All right,
Yeah.
let's see. So there's wonders of the ancient world and there's wonders of the world, right? The wonders of the ancient world are like the pyramid,
Yeah.
Colossus of Rhodes.
Okay. I didn't know that one. I believe you though. I know one more.
Is the Parthenon one of them?
Ooh, it's either the Parthenon or
Or
the
the
Pantheon.
Right.
Yeah. Okay, we'll count one of those.
Colosseum?
Okay.
Is that one of them?
Yeah. There's also the Hanging Gardens of Babylon.
The Hanging Gardens of Babylon, that's right. I'm out.
No idea. All right. Well, we could look that up on Wikipedia.
We will look that up
if we need
another
it.
day.
Yeah.
But yeah, the dress rehearsal, as the judges are telling us, the dress rehearsal lasts 2 hours. We're about 40 minutes in. Do you know if there is going to be a freeze today?
I would expect there's some sort of freeze. It's an interesting technological edge case to check.
Right.
So probably the people who run the scoreboard want to make sure that it's all working and stuff.
Yeah, so a problem freeze typically happens in the last hour of the contest. Sorry, this is not a problem freeze, it's a scoreboard freeze. So in the last hour of the contest, teams no longer can see the scoreboard of what other teams are solving. Teams obviously can still submit themselves, and they can also see the results of their own submissions, but they don't, the scoreboard stops being updated. Actually, that's not entirely true, right? The scoreboard... Sorry. Hello.
Welcome. How's our audio sounding?
Yes.
I'm sorry.
Like this low frequency is too high. Maybe.
All right, go ahead.
I'll try. I will try to.
Yeah.
Put this on.
Okay.
See again how it works.
Yeah,
Alright.
there is a little bit of... Sorry. There's
Do you
a...
plan to have guests here or not?
No. Well, just 2 people.
Yeah, just 2 of us. One of us will leave.
Yeah.
Yeah.
That's kind of strange.
Yeah. I think. Yeah, we'll see. This room also, just like the rest of this contest, was constructed just for this event.
Yeah, this isn't actually like a real room. This is like part of a huge box, and then the room is like these walls were built a couple days ago.
Right. And so it's a little commentary booth just for us. There are 5 other booths just like it, right next door, and we hopefully will have commentary in six
different languages. Yeah, English, Russian, Chinese, Portuguese, Spanish.
We'll see it. We'll see
Maybe
exactly.
not. All right,
We'll see exactly.
No promises.
No promises. But look out for that. Hopefully we get as many commentators as we can.
Yes.
And hope it will be a good time.
Oh,
no
we
matter
also have
what.
Russian. I don't know if I said Russian.
Yeah,
We've
we
got
have Russian.
Igor doing the Russian stream.
Right.
Many of you may know him.
Right. So that will be that's definitely going to be something to look out for, and maybe they will have some insights that we don't. But we'll try our best to get all the information to you guys as well. Yeah. So did you see what they just showed Warsaw was testing?
It wasn't quite. Oh, more testing from Warsaw.
Looks like they're testing the ability to check the clock.
That's really strange. So if you plan to have any guests, you don't have any guests. You have some sponsors coming. So let's try to add some noise filter just because these fans are too loud.
Yeah.
And they,
Yeah.
so that's your mic, right?
Yeah, that's right.
Let's add some noise suppression and see if it works.
Okay.
All right.
Thank you.
Another option is we could leave the door open.
We could leave the door open.
That would make things more
We could also try We could also try shifting the setup a little bit, but we'll play with it later.
Like away from the mic.
No, away from the door. So that.
Oh.
Because it's just my chair that's in the way.
Oh yeah, for the in the way.
Yeah. So, but yeah. Well, Warsaw was testing. It's gone from the screen by now. But
Did you see it?
yeah, they were testing this for loop, which is like while they were checking time and checking like they were running a loop that was like while time less than 5.1 seconds or something.
Oh, so they were seeing if they could squeeze in a 5.1 second submit.
Yeah, or they were testing their code that just like if it runs in a loop, does clock work, and do these functions work, right? And that's sometimes C++'s compatibility and portability is not perfect, right? Some systems might support it a little better, it might be a little less accurate somewhere, and so it's important to test that like these functions work the way you might expect, and they're accurate enough for your purposes.
Speaking of testing how much time you've got, UW-Madison has, 10 submissions to problem E, all time limit. And what's kind of funny here, it's not like all three of their teammates are trying to get different submissions in here.
These are all to the same problem, and if I had to guess, they might all be the same code.
And they're all from the same person. UW-Madison, believe it or not, 2 of the 3 teammates got sick with COVID, and they're not able to compete today. So UW-Madison is represented just by a single individual.
That's pretty tough.
It is. It's quite a bit of courage that it takes to go walk on a stage, compete against all the other best teams, best programmers in the world.
Right.
When it's just you.
Right. And some people, it might sound like it's not a big deal because, after all, there's only one computer, right?
Yeah. I mean, you got the computer the whole time all to yourself. Can't type any faster.
Right. But, there really is a lot of teamwork that goes into these teams.
It takes a ton of effort. The difference between having one person and having 2 people in a contest is huge.
Right. Because you get so much, you can have someone else read new problems while you're typing problems. You can have them, help you debug while you're typing new problems. You can talk. Talking about problems is something that sometimes is a waste of man hours, but sometimes it's really important for solving these hard problems.
Yeah, I mean, certainly most people in the world, probably most people in World Finals even though these are the best of the best, you can't just look at a problem, see the solution instantly.
Right.
These are hard problems. These are as tough as it gets. How's our audio?
You miss me? Much better. So
Our audio is much better?
it eliminated the sound of this fan. Yeah.
It's that fan.
That fan, but yeah.
It's that fan.
Yeah.
Ah.
And it only happens when the door's closed.
That's why. Yeah.
It's interesting.
Yeah.
What'd you do?
I want to add some. It's John's. John's on. Yes. So you have the sound from the stream. Is it your stream? No. This. No, this is your stream. Yeah.
Yes.
And you have sound.
The sound is. Yeah, it's a little quiet, but that is the.
No, it's fine. It's quiet, but it's not. No, it's not. It's not suppressed. I don't hear the sound at all in the stream. Why? Your N out. Magic. I don't know. I don't hear the sound at all.
We can try maybe
You don't hear
muting
what sound?
us for a minute.
Yeah,
Seeing if you hear
let's
us.
do it.
Okay.
What the hell? Why so no? Is it automatic?
No. It's just when the door closes, the airflow is different, so this fan just gets way louder. When the door's closed.
I got it.
Yeah. Okay. Yeah. Let us. We might go on mute for a minute while we test out some audio. We want to make sure that you guys can hear. We have mics. Each team has a webcam, right?
Yeah.
I believe that webcam also has mics.
Yes.
And I don't know if we're always listening in, but we should be able to sometimes hear the team's mics, especially when they're celebrating on their submits, right?
Yeah, so I guess quick summary of how the audio works in case anybody cares. We have these mics here. Other teams have equivalent versions of these. And we have our own camera. So we've got one set of, I guess we have 2 audio
Right.
inputs here, a third input here. And then in addition to this, you see the team floor on this stream. we have cameras on that stream listening to the team. So if there's like a round of applause or a first solve or something, lots of
Right.
people will clap and you'll want to hear that. And we've got that going in too. So it's kind of like a football game where you hear the crowd a little bit.
Right.
And we're trying to balance all of that.
Trying to make sure that you guys can hear the background noise, the floor noise, sound of teams shuffling their papers.
And at the same time, not hear the fans in this room trying to keep everything below 90 degrees Fahrenheit, 30 degrees Celsius.
We're trying not to burn up in here.
Yeah, it's gonna get hot, but we're doing our best. So yeah, that's just trying to
Yeah.
make sure that's all good.
Yeah, so I saw earlier the ticker was saying that MIT was the first team to solve a problem in Python.
Oh, nice.
Yeah. So do you know what languages are allowed at this contest?
I don't know all of them, but I know they do allow C,
Yeah.
C++, which is
Right.
by far the most common,
Right.
Java, which
Right.
is what I used when I was competing,
Right.
Kotlin, which is made by JetBrains, one of
Right.
the ICPC sponsors,
Right.
and
Python.
what else? And
apparently.
Python.
Right.
Yeah, and I
Right.
think those are the most common ones. But
Those are probably the most common languages that people might use. Right?
yeah, I think there are other ones that are allowed, but they're just pretty uncommon.
A little more, a little rare. Yeah. And so one thing that people often use Python for is problems that involve big integers, right? And people sometimes use Java for that too. That's what my team typically did.
Java has a big integer class, which lets you handle integers that are bigger than even a billion.
Right.
A billion times a billion.
Right. They can handle integers up to, like 10 to the 1,000 or
Yeah,
something.
yeah, huge numbers.
Right.
Python can too,
Right.
and Python used to have a fantastic way of converting between strings and integers. It was
Right.
a little
Called
slow.
int.
Yeah, it was a little slow, called
Right.
casting it to an int. Yes.
Right.
And then there was some drama, and that got removed.
Right. I think, there was some worries that the runtime of this was, this is a real thing, right?
Yeah, it exists, yeah.
If people sometimes if someone were to give you a very large string and you try and cast to it, and this string is like length 1,000,000 or something, it will actually just take hours and hours in Python, right? Because the algorithm they use might not have been totally optimal, or it might not have been perfectly optimized.
It's also just like a hard thing to do, converting a really big number from base 10 to base 2.
Right.
It's a tricky problem.
Right,
Even
right.
if you're really smart about it, it's a hard thing to do.
Right. I actually don't know of any. I think the fastest solution I know is takes like n log squared n time, which is quite a big runtime. It's not easy to implement.
Yeah.
So they I believe made the decision that in order to prevent if I'm running a server and I'm parsing integers from like HTML HTTP requests or they wanted to make sure that you couldn't just like totally bring down the server for an hour or forever by giving a really big integer, and so they actually added a limit on how big an integer you can parse in Python.
It says Warsaw is now submitting memes. Is this some sort of meme?
I guess they are just submitting.
Does this evaluate into like some integer that's comical?
I don't know. I'm really not sure what they're submitting. Maybe they're just trying to. One thing is they're submitting. This is a very long for loop. That's one thing that they're doing. They're actually submitting. If you saw, the for loop actually looped up to 5 times 10 to the 8 iterations.
Take almost 5 seconds.
And so I think what they're probably trying to do is they're trying to test actually how many iterations you can run in the time before you get a time limit exceeded.
So we got a question here. Do you think there's an advantage of using multi-threads for independent calculations? Now, I usually go by the handle second thread, so I'm pretty partial to using a second thread.
Right.
But a lot of times, just having everything in the second thread is better if you use Java, because that way you can have a bigger stack size if you have a large recursive problem.
Interesting.
If you run 2 threads in parallel, though,
Right.
you have the time you spend in the first thread and also the time you spend in the second thread.
Right.
You think that gets added together in your final runtime total?
Yeah, so the way timing works in ICPC is that I'm not 100% sure about the Java garbage collection thread, but for the most part, they take the total CPU time, which is the total amount of time that every thread uses all added together. So if you use twice as many cores, each doing half as much work, each taking half as much time, then it actually has the same runtime. So you don't really get any you don't really get any speed up. I think ICPC, I don't remember exactly whether ICPC disallows parallel processing or whether it just doesn't give you any improvement because you're still just using the CPU.
Yeah, like if you spend the time to create a second thread to do half the work and you still do the same amount of work, your
It's
time's
not
going
any
to be
faster.
like even slower, yeah. Like
Right.
you'll have the extra just overhead of making that thread. So really the only real time you would want to make a thread is if you want to transfer everything to the other thread.
Right.
Do it all there and then transfer it back.
Right, just to make it as if, just to start up a second thread with
Yeah,
more stack.
yeah,
or
just to like
something
have
else.
better stack settings, yeah.
Yeah. So parallel processing doesn't really help in ICPC, but it definitely is something that is pretty interesting. There was a programming contest that was run 4 or 5 years ago, right? Called Distributed Code Jam.
Yeah,
right?
Google Distributed Code Jam.
Which was a pretty interesting contest format. I believe it was actually inspired by a Polish contest format, Polish
Interesting.
contest once. And in that contest, they actually ran your code on many different servers, and you had to communicate and things. And so there's definitely a lot of like room for like these contests to branch into these parallel processing or distributed computing kind of domains, and that'd be pretty. That would be pretty interesting to see someday at ICPC.
We saw the expansion into interactive problems.
Right.
And kind of a natural next step is like what can be an even more interesting, novel type of problem that you could do, and some sort of like distributed thing would be interesting.
Right.
Lots of interesting options there.
Right. So here we see we are actually able to highlight particular teams. You can see that we're actually circling MIPT and St. Petersburg State University. That's pretty exciting. I am pretty impressed by how far this overlay has come.
Yeah, we started with with just the bottom bar. It looks like lots of stuff is being tested here.
Yeah.
We also have some nice balloons in the contest. You'll see
Right.
we've got a black one in the bottom right corner.
Right.
And I thought I saw some blue ones. Oh yeah,
Yeah,
there
there's some
are
blue
blue
ones
ones
floating
there.
right
They're
there.
just like kind of difficult
Yeah.
to see with all the very noisy
Yeah.
screen in the back.
Right. Yeah, I mean, that is one of the things that they're testing. They're making sure that they can direct the right volunteers with the right balloons to the right tables, right? And they want to make sure that those systems work just as well. Yeah.
So one of the things you'll notice here, a contestant during team registration the other day brought this up to me.
Mhm.
There is just this massive, absolutely gigantic scoreboard. And it is totally unignorable.
Right.
You will see it if you look in the left-hand corner of the room. Is there? You got all these teams, and you can kind of see a little bit of it in the background here.
Right.
You can see, yeah, it's a different UI than what most of the online websites have, because it's this kind of dark theme.
Right.
But
And it's not a table necessarily, more as just each team with their list of solved problems.
it's got some interesting scrolling animations. Ooh, and we just heard a massive decrease in audio from the floor.
It looks like
Maybe-
our stream
Maybe the stream is
might have
frozen.
But no, I guess
We're
we still
still
see
here.
the stream. The stream is still working. What is
we're
this team testing right now? They are. This is University of Asia Pacific testing the judge, and they seem to be. Can you tell what's going on here? I think they're one thing that's interesting is they're setting these three flags. Do you know this? Do you know of these 3 flags? I don't know if you're a C++.
I didn't quite read it, but it looked like they were setting the standard input to have I don't know, be fast, standard
Right.
output to be fast,
Right,
and
right.
print line to be fast.
Right. Yeah. So there are some flags you can set to make sure that your C++ output doesn't lock and doesn't buffer too much, or buffers it the right amount and doesn't flush.
My best educated guess there is that was either their template, which they submitted by accident,
Right.
or their template, which they submitted intentionally,
Right.
in order to see what the total overhead that
Right.
it takes to actually just run the code.
Right.
is.
Right. There's some amount of startup time and some amount of compile time, and you just want to understand what that might how that might affect your runtime.
Yeah, is it like a millisecond? Is it like 30 milliseconds? How
Right,
much wiggle room do you have really comes down to the wire.
Right. Yeah, so we are almost an hour into the contest, and it looks like teams have teams have mostly started quieting down. We can see that there actually are some coaches on the floor. This, I believe, during the dress rehearsal, coaches are allowed to be there to, help the students and, just make sure that they're doing that. Everything is set up the way they like, right?
One of the people in the chat asks if you're allowed to come watch. I know coaches are allowed to come watch, and above this booth on the far side, you see this wall. But above it, actually, we have a section for coaches, and there are quite a few seats there.
Right. I think it is open to. I'm not sure it's actually.
I don't know if it's open to the public, but certainly there's less security today than there is tomorrow. Tomorrow it is taken incredibly seriously.
Right.
Nobody other than the volunteers who are specifically allowed to distribute balloons,
Right.
the press, the ICPC press,
Right.
and the contestants are allowed on the floor.
Yeah, I think by the end of today, we will no longer, like even us, setting up webcams and things for the teams, I think we will not be allowed to touch those, and all modifications have to be done already. So it's really going to go into real strict lockdown by the start of the contest, and so we'll see how the security ramps up.
They do usually have some members of the ICPC News taking some pictures.
Right,
but,
right.
We can't touch computers. We don't touch anything. And
Right.
It's not us. It's
not us. Yeah.
It's other people.
We don't have the security clearance.
Yeah. We're just here talking heads on a camera, right?
Right. They don't trust us. I mean, we've already admitted that we might have favorites. So
Yeah.
They probably will never trust us again.
You can see a little bit of the scoreboard on the background. We have a production crew.
Yeah.
Who are showing you some of the scoreboards here. They'll flash through lots of the interesting things as we go.
Yeah. They're.
For instance, National Taiwan University submissions, which we just saw. AC's on everything, it looks like.
On everything already. Wow.
Fake.
Yeah. Yeah, we can see that there are. Looks like the bottom of the top teams have 4. Yeah, we're looking for the scoreboard as well. And now, right now we're looking at UCLA. Can you tell what UCLA is using? Is that Sea Lion?
I didn't quite see.
Yeah, so
their screen.
I think they were using some IDE, probably either Sea Lion or IntelliJ. There are a variety of tools that you can use. The computers that contestants use this time are they're provided by ICPC, and they contain completely blank operating system installs. So everything is pre-configured, and it's to make sure that you don't manage to smuggle in any like hidden communication channels or smuggle in any hidden notes to yourself that you're not allowed.
Yeah, or hidden book code or anything. You don't want your FFT code hidden somewhere.
Right, but they are preloaded with a lot of different IDEs and editing environments that hopefully will cover most people's cases. I think, in fact, if it doesn't cover your case, you can actually request one. But among them, there's a lot of the JetBrains IDEs, which JetBrains is a sponsor, and they've graciously provided keys for all these teams to use the IDs. There are Sublime Text. There is Genie, which some people like to use. There's VS Code. There's Vim and Emacs.
VS Code is a common one. I think it's surged in popularity recently.
Right.
They also have Eclipse if you use Java.
Right.
That exists.
Right. I think they might have Code Blocks as well, which is a bit of an older C++ IDE. Yeah.
What did you use, Andrew, during your time?
I've always been a Vim user.
Just straight terminal.
Straight terminal.
That's all you need.
Yeah.
All right, so we're going to have a quick break here, and I'm going to draw the Kotlin logo for you guys. So if I remember, it looks something. Oh, that's the eraser. Here we go. Kotlin logo. I think it looks like this.
Right.
And then usually they have like a gradient here.
Right.
And that's a little bit different.
Right.
But it might be the bottom half. I'm gonna be honest, I kind of forget.
I think it might. Does the line go the other way?
Oh, does it go like this? Yeah, like that.
I think it might go the other way. I don't remember anymore. So funny story. We actually. I don't know if you guys caught our earlier stream in the registration hall, but we while teams were registering, we set up a nice set of couches and got to lounge around and talk with the teams, and actually all the floor tiles in the registration hall they looked like that, right? They looked like these little triangles.
They all had this Kotlin logo, yeah, like this.
Yeah, and so,
I'll draw it for you here while I'm practicing. There we go.
Right.
That's kind of a Kotlin logo. All right.
Right.
We are done with this. We just wanted to test this out.
Make sure that we can talk about all the problems.
Yes.
Make sure that we can talk about all the problems with you guys. Draw any diagrams that we need, and hopefully we'll be able to show you anything interesting about the problems.
GitHub Copilot. That's an interesting suggestion.
Right.
Are you familiar with it? Have you ever tried it?
I used it for a little bit while it was technical preview or whatever. It's definitely a pretty cool tool.
It does way more than you would expect, but it isn't quite game breaking.
Yeah, I think Copilot at the end of the day is really good at copy pasting it's really good at doing things that are like kind of rote and mechanical. So if you were going to copy paste a bunch of code and then you wanted to do some refactor on that, like it's pretty good at copy pasting a slightly different version of the code, right? It's pretty terrible at algorithms. There was one time when I tried to type like a for loop, and Copilot's suggestion was 11 more nested for loops.
Yeah.
So it's it doesn't always know exactly what it's doing, but it is really nice for boilerplate. But I think it's not too game breaking for competitive programming, where so much of it is about designing these novel algorithms and not about just like making sure that you like copy paste this code for like these 5 different it's not about like interfacing with these 5 different APIs or anything. It's about it's really about the algorithms.
I know Google let some ML engineers loose on a Codeforces project where the goal was write a bot that does well in Codeforces.
Right. That was also pretty impressive.
The results at the end of the paper were insane. They were like better than 60% of the users on Codeforces, and on an average contest they would have been they would have beaten like 30% of the people there, which is pretty impressive. I mean, it's not even a person. It's like a rock.
Right.
It's a thing in a basement.
Right.
No life, nothing.
Yeah. And they did there were some really, really tricky things. If you looked at some of the code that they submitted, they managed to do things like prefix sums, and they managed to do things like, we want to sum up everything except each element, so we'll add them all up and then subtract out like a particular element.
Now, at the same time, I think there's a little bit of balancing we have to do here. If you look at how their AI worked, it did some sketchy things.
There were some things in there.
There were a lot of stretches that were being made in order to get to that result. But it was all legit.
Yeah.
And it did do that.
I mean, at the end of the day, the code compiles and passes problems some of the time.
And it's a better programmer than a few people.
Yeah.
Like after the 10 tries it's got, lots of work, but it gets there. It gets to a pretty good spot.
Yeah. Some people are asking if you can copy code from the internet. ICPC has some pretty interesting rules that are they're kind of honestly, I really like these rules, but they're pretty tough to enforce if it's not an in-person contest. But the way that ICPC works is that teams are not allowed access to the internet at all. That would be far too hard to check, right?
Yeah.
To regulate. But they can get access to they can bring 25 pages of printed reference documents.
So it's your 25-page hack pack, your library code, book code.
Yeah. And
it can have all of the algorithms you want. It can have anything you want. It can have notes. It can have strategies.
It can have math. It can have formulas.
It can have pictures of the Mona Lisa. Although most people usually probably wouldn't pick that.
It can have a reminder to eat. It can have checklists for you.
Yep.
Yeah.
And it is limited to 25 pages. It's got to be readable at arm's length by a person with like normal vision.
You can't just bring a magnifying glass.
No magnifying glasses allowed.
Yeah.
No RGB or like 3D goggles.
Right.
One red, one blue. Close one eye, close the other eye, see something else.
No. 25 pages, fair and square. Right.
Fair and square. Single side.
Right.
And you're limited to that, and that's the code you're allowed to bring in. But you have to have that all ahead of time. You can't use the internet. Teams don't have access to any of the internet except what they use to submit to the judges. That's the only
it's not even the real internet. It's just some internal network that we've set up here.
Yeah.
The reference document is pretty interesting because it's printed on paper, right? You can't actually copy paste from the reference document into your computer. You actually have to sit someone at the computer looking down and typing it up by hand.
And if that's not something you've done before, it's a trickier thing to do than you might think.
Yeah.
Like, reading code that's not on the screen and typing on the screen is a bit weird. Sometimes people will put it, like, over the monitor. They'll, like, fold it over the monitor and read it there. That way, at least they're looking next to where they're typing.
Right.
But yeah, it's a lot of blind typing.
Right. And I mean, it's still totally worth it. Like, there's still a lot of these black box algorithms that, implementing them can be a little bug prone, or it can be a little, just a little time consuming to just think through the edge cases and the details. And it's just, it's better to just have this book code, which you're able to just have this code written up for you that is correct, and you're able to just type up.
So one of the things that you showed me, Andrew, was a thing that your team does.
Yeah.
In order to make sure that once you've typed your book code, you don't have any issues with it. You didn't make a mistake, accidentally type a J where there should have been an I.
Right.
What strategy do you guys use in order to avoid those problems?
Right. So we actually we actually implemented some custom scripts in the way we built our book code that every single block of code, it will print at the end of it, it will print out a hash of the code, and the hash is computed using just like whatever tools are on the computer. So I think we used MD5 sum, which is just built into most computers.
And for people who aren't familiar, a hash is just like you're given some block of code.
Right.
It'll read the code, and if you change any little bit about the code, the hash will change completely. It'll be a completely different random number.
Right. The hashes are pretty much they're kind of magic. Hash functions are kind of magical. They're just deterministic functions, but they look pretty much random. Right.
Yeah.
And so if you change the input a little bit, it doesn't matter. Like the output looks totally like a totally new random number.
So what this will tell you is if you type in your code and you do it all perfectly right, you'll get the exact same hash function or hash code, hash value as what you have printed on your book. So you can verify that you got it right.
Right.
But if you made any mistake, it doesn't tell you where the mistake is. It just tells you something you did was wrong.
Yeah. One trick's that there's actually a trick to actually help you figure out which line of code is wrong.
You do like intermediate hash functions, so you can kind of binary search the issue.
Right. What some people do is they make a hash of every prefix of the code, and so you select the first half of it and you hash it, and you check if that matches the first half hash, and then you just select, and then if that mismatches, you go to the first quarter. If that matches, you go to like 75%, or a little bit beyond that, and you can actually binary search to find which prefix is wrong.
Yeah, that makes sense. That's an interesting strategy.
Yeah.
Certainly saves time in looking through finding the issue.
Yeah. And I mean, another thing you can do, which honestly I think is probably the better thing, is if the hash doesn't match, you can just print the code. And that's something that teams can do. And that's something that teams can do in this contest. That's probably something that teams are testing. We don't have any way of check. We don't see that on the scoreboard or anything.
So all of the teams have access to printing any text file that they want.
Right.
And they can either run a command from the terminal, or I think there's a UI where they can do that sort of thing too.
Right.
And when this happens, they'll just send it to a printer, and you see there's a guy in a white shirt here walking by with a sheet of paper. He's probably delivering a print job to one of the teams who requested it.
Right. And printing is a kind of interesting thing because it really matters the most in these contests where you have one computer, right?
The one computer, it's a huge, like, you only have one person who's allowed to look at the current code at a time, or I mean, who can use the computer, use the keyboard, use the mouse. But other people can, if they have a bug, they can write their code, and once they want their teammate to be able to use the computer, they can print that off, and then they get the physical paper copy of their code, look at that, and then find the bug while looking at the paper copy. That way, you can parallelize the use of the computer.
Right. And I mean, printing, like, honestly, like, maybe this is something that maybe we should all do more, like, even when we have only a single computer, or like one person on one computer, because it also is kind of nice to just have a different way to look at the code. You can, instead of like looking at it in the same font size, it like changes the color scheme, and it changes how it looks, and sometimes reading it in a new light actually can help you find a bug.
It's like one of those times where you've seen those. I'm sure you've seen the things where you've got a picture, you've got some text, and it'll like you will read the text incorrectly.
Right.
But it really says you will read the text incorrectly, and the two those are on the end of the first line, beginning of the second, and your brain just auto corrects it.
Right.
But when you finally see it in a second version, and it wasn't the version you typed.
Right.
You're less blind to what your bug is.
Right. Yeah.
Especially if it's something silly like that.
Yeah. So it can totally help a lot, and I hope that teams are testing that out and are taking full advantage of that.
All right. Can you see what this URL is? Can anyone look at the URL that they see on the screen and put it in chat?
Well, I think the URL that they're using is probably a network internal one that
All right.
isn't open. I believe the scoreboard is supposed to be at icpc.global/scoreboard, but I believe it is currently giving a 502 error.
All right.
And so
Dang.
we might we're working on that, and we'll try our best to get it working by the end of this contest, right? We'd really want to see it.
We have some very, very capable people here in the production side of this.
Right.
Who are showing us certainly the most interesting part of the contest. But I would just, even when I'm streaming, I want to see
Right.
the scoreboard, want to see if someone AC'd, and
Yeah.
then we can give you guys the most up-to-date news.
Right. Yeah, I mean,
Yeah, kinda here.
we're all, at the end of the day, we're also just fans, right?
Yeah, we just want to see what's going on.
We just want to see teams getting AC. So that's hopefully we'll be able to see that.
We've got some disagreement in the chat on whether Python or C++ is a better programming language to use in these programming contests. What do you think, Andrew?
I mean,
I think I know what you're going to say, but what do you think?
I mean, it's, I don't have any way to put it lightly.
Andrew's
but,
submission history does not have a lot of Python
I
submissions.
don't have a lot of Python submissions. I mean, I've used Python for some contests. In fact, I actually use Python a lot during things like admin of code, right? Where runtime really doesn't matter. It's not so much competitive programming. You're not really thinking hard about algorithms, and you're thinking hard about like how to make this code like simple and easy to reason about, right? Simple to write, easy to read, easy to make sure it works, right? And Python is pretty good there. But anytime you care about algorithms, anytime you care about runtime, like C++ is really where it's at. You get like direct control over memory allocation, and you get direct control over like how things are passed on the stack. And also C++ has so much power with, I think C++ really unwraps so much of like reference, so really shows you so much about how like references work. There's L values and R value references, and they work so well. that's really what it.
So I have an answer that people might not see coming.
What's your answer?
So the question is whether C++ or Python is the best language to use. The answer is no. Java is the best language to use. Because when your code doesn't work, you know exactly which line it crashed on, you know exactly what the bug was, you know what index you tried to use, and it didn't exist, you know the size of the array when it crashed. You know all these things. Very helpful.
Right. Yeah, I mean, one thing is that C++ is a bit of an old language. It's got a bit of cruft. One thing about performance optimizations is that if you're trying to optimize performance, you don't the compiler assumes that everything is going to work correctly. It's like, well, it's going to work correctly, so I'm just going to look 2 steps ahead. And when it does crash, it's like, well, you asked me to go as fast as possible, so I threw out all the information about what might have gone wrong.
I have run into a wall because you told me to, and I didn't bother tracing where I was before running into it, because that would have taken time and I would have gone slower.
Yeah, you told me to run as fast as possible, and it's your fault that the wall is there.
Yeah.
And so, but fortunately, actually, the state of C++ tooling has gotten a lot better in the past, past 5 years, decade.
Is there an easy flag you can do to just say, like, when I crash, tell me what line, how big the array was, how big the vector was?
Yeah, so there actually are these projects called, like, UBSAN, or Undefined Behavior Sanitizer, and Address Sanitizer, and things like that, which actually, like, track all your, track your accesses and track everything, and it's like a flag you have to pass when you're compiling the code, but it will actually compile a version which, is a little bit slower, but will actually record, where things go wrong.
A common one I've seen lots of people use is the fsanitize equals address.
Right. That's right. That's address sanitizer.
That's a big one, yeah.
fsanitize equals undefined is UBSAN.
What is
for undefined behavior sanitizer.
Oh, so it's even more.
Yeah, so it sanitizes. Well, it actually sanitizes a different class. Different class of errors, or it checks for a different class of errors.
Like if you try and rely on some variable and you haven't set it to something.
Yeah, undefined behavior sanitizer focuses on uninitialized things and things like that, and address sanitizer focuses on uninitialized or freed memory or array out of bounds and things like that, I think.
All right.
Yeah, so there's definitely a lot of room for them to. There's definitely a lot of tooling that exists now. Also, GDB, learning how to use GDB is a good experience, and that also helps. That also helps debug your code. So that's another thing. Yeah. Yeah, people are talking about whether C++ or Python are slower. C++ is faster. That's just the fact.
They do not. So in IOI, they
Yeah.
have different time limits for C++ and Python and Java. In this case, they don't, right? Everything is, you get the same time limit. Some problems, they're just going to be impossible to solve in Python, and that's how it is. You got to use a better language, or
I'm
a faster
actually
language.
not 100% sure that's the case. I think that's the
Really?
case.
I think it is.
Okay,
I'm
well,
pretty sure it is. But
You're the
could be
Java
wrong.
man here. I just always use the fast language, so I just always see the time limit and use the time limit. But might be, yeah, they might all have the same time limit.
I know judges do. One of the things we do know here is that judges have written solutions in at least two of the three languages, two of the
Right.
three classes. So either C, C++, that's one class, Java, Kotlin is another class, and then Python is a third class.
Right.
And for every problem, they've solved in at least two of the three languages, so it's possible in at least two of those.
Right.
You don't have to use C++ for everything.
Right.
But yeah, you can if you want to.
Right. Yeah. Yeah, Kevin is pointing out that only C++ is supported in IOI. That is in fact.
Oh, never mind. Okay.
That's well.
Am I
See,
thinking
the
of
other
Soccer?
languages. The other languages were supported in the past.
Oh, okay.
But
all
they've
right.
since they kind of too few people at IOI use them, and so supporting them became just kind of a large maintenance burden. Because you have to remember, all of the judges and all of the problem setters and all of the people who manage the contest system, they're all volunteers, right? And so this is all just on their their volunteer time. And if you spend a little time preparing for Java, you might be able to write a lot better tests for C++. And so that's it's a trade-off that sometimes you have to make. So it looks like we have two teams that have finished so far, right? In the standings, we have
And potentially a third.
potentially a
Look
third.
at Oxford's got 2 submissions to the only problems they haven't solved, and it looks like they've also solved. Yeah, okay, well now they've solved everything, but they had already solved E. So if you submit the same code to J, you'll get it right.
Right. And and one interesting thing I think was that the Tinker has told us that what was it, National Taiwan University was the first team to solve all problems, but actually Swarthmore is higher than them on the scoreboard. Yeah, and that can happen for a few different reasons, right?
Yeah, so I guess this would be an interesting time to talk about the way penalty points works here.
Right.
It turns out, obviously, the goal is to solve the most problems. So if you
Right.
solve more problems than another team, you'll
Right.
be higher ranked than them.
All right. Every problem is a point.
Yep.
Same point for every. Problems aren't weighted. Every problem is the same.
And that point is currently represented, the number of points you have is represented by the sigma, the
Right.
sum symbol, kind of like a backwards E,
Right.
on the second column of this chart here.
Right.
So if you have more points, you're going to be higher up. But if you have the same number of points, we use your penalty, also called your penalty points, unrelated
Right.
to points, and penalty points are bad. You
Right.
don't want penalty points.
Right.
But it's better to have one more problem correct and an infinite number of penalty points.
Right.
So even if it takes a ton of wrong submissions, it's good to get another problem. But you want to minimize the number of penalty points you have, and there are two ways of doing that. The first is to minimize the number of wrong answers.
Right.
So you'll see here, IIT Bombay, they've got 4 incorrect submissions to problem A.
Right.
If they were to get it, from those 4 incorrect submissions, they would get 80 penalty points, 20 penalty points for each wrong submission.
Right. Yeah, I mean, luckily you don't get penalty. You don't get penalty for wrong answers for problems that you don't end up solving.
Yeah, you only get the penalty points once you've gotten the problem right.
Right.
And then in addition to getting those 80 penalty points for getting the problem incorrect 4 times,
Right.
they also get more penalty points for how long it's taken them to solve the problem. So if you solve a problem 30 minutes in a contest, you'll get 30 penalty points, one
Right.
for each minute. And then you might also get additional ones if you got it wrong sometime in those 30, and you get all of those penalty points assigned to you when you get the problem right. And you'll
Right.
move up on the scoreboard, certainly, because you have another problem. So you're
Right.
better off, even if
Yeah.
it takes you lots of wrong answers and lots of time to get a problem.
Right. And yeah, and so one interesting thing is that the penalty minutes, the penalty time for each problem is calculated from the start of the contest, right? And so one way of thinking about it is that the first problem you solve, how long it takes you to solve that counts for its own penalty, right? But it also delays you working on all the other problems, right? And so actually, the first problem is kind of the most important to be the fastest. It like every minute that you spend here results in a penalty minute for this problem, a penalty minute for your next problem, and for every single problem for the rest of the contest. And so this is a pretty interesting system, and it means that you really should be solving fast problems first, right? And you've also got to be, you got to be pretty good at fast problems, right? When the problem is simple, you got to be fast and accurate.
Yeah, the way the scoring works, obviously you want to prioritize the problems you can solve faster first.
Right.
But there's also this like kind of interesting sub-strategy
Mm-hmm.
where the 20 penalty points and the amount of time it takes you to solve these problems kind of conflict.
Right.
Sometimes you can spend an extra 5 minutes and make sure you don't get it wrong.
Right.
But is that worth it? And it turns out like later on in the contest where if you only have one more problem left, of course it's worth it.
Right.
But earlier on in the contest, if you spend an extra 5 minutes, you're spending an extra 5 minutes for this problem, but also for all of your future problems, because you're
Right.
spending the 5 minutes early on in the contest, and those minutes are more valuable. So
Right.
maybe you want to be more fast and loose in the beginning contest.
Right, right. Sometimes it's worth it to, one thing that we often did that, could be good is you just submit the problem and then you also print it at the same time. And so, in the best case, you just have an extra sheet of paper because in the best case, you get AC and you have an extra sheet of paper. And in the worst case, someone has already started working on the next problem and you can debug it on paper if it turns out to be wrong. And so that's another strategy that teams might use with the printer. Yeah, one thing we can see is that NTU had many more wrong submits, right?
Oh, okay.
Yeah, I believe they had plus 8 wrong submits.
Gotcha.
The way that this scoreboard reads is that plus just means it was correct on your first submit. Plus 1 means that it was correct, or plus 2 means that your third submit was the correct submit. So you have 2 incorrect submits and then your correct submit. And minus 2 means that you have 2 incorrect submits and have not gotten it correct yet.
We see some questions about balloons here. So why, even if teams are getting like 8 or 10 problems correct, why do they not have 10 balloons? We're not using balloons for every problem
Right.
during this practice round. There will be balloons for every practice or for every problem in the real contest tomorrow.
Right, right. We don't, we are trying to test everything, but you don't have to test every part of everything.
We don't want to run out of helium either.
Right, right. These balloons are, there's a lot of them for a lot of teams.
It doesn't seem like much to just, it's 2 balloons, 4 balloons, what's the difference? But when you multiply it by, 136?
Right.
Yeah.
It's a lot of balloons, a lot of time to inflate,
Yeah, yeah.
Have you ever seen the balloon room? I'm kind of curious. I've never been inside of it.
At NAC,
Uh-huh.
I saw it.
Right.
And in part of setting up the unofficial stream for NAC, there was walking past, and just the amount of balloons there was kind of insane.
Right.
Because especially in the beginning of contest, there's this huge influx.
Right.
And you just don't have time. Like teams, you get 10 teams solving in a 1 minute period. You don't have time to inflate 10 balloons in a minute and tie them and get them all ready and give them to someone and tell the person what desk to go to. It's just too much stuff to do. So you have to have the balloons pre-made.
Right.
And I'm sure they have them somewhere. I don't know exactly where they are though.
Right, right. Yeah. I'm sure they're just in some room, hidden from view.
One of the fun facts that people might not know here is there's actually a ton of security that goes into the balloon part of the contest.
Mm-hmm.
The judges want to be really careful not to give any information about which problems are easier away by any of the balloons.
Right.
So they're very secretive with the balloons, but also they'll order lots of balloons of all of the different colors.
Right.
And I think they don't even tell the balloon operators which ones map to which problems until the contest starts.
Yeah, I mean, we don't even actually know how many problems there will be.
We don't. We don't know how many problems there'll be. We don't know how many balloon colors there'll be.
Yeah, they ordered like maybe 16 or 20 different balloon colors, which is definitely more than the number of problems. But this way, we don't even know some of these balloons might go to waste because there are just fewer problems, and they don't want to leak there are actually only 13 problems in this set.
We will save the problems or the balloons for next year in this case.
Yeah, yeah.
So Andrew, we've got a question about tourist Genna.
Right.
Any information there?
Well,
I don't know. Are we allowed to share the information? Might be top secret.
No information there.
No information.
No information there. We can.
We haven't forgotten about him.
We haven't forgotten about him. He might appear on
be
some stream tomorrow.
There are rules, and we have to follow the rules. We'll
see. We'll
try
might
and get him on tomorrow. But
yeah, he might appear. We might call him in. He might appear on the Russian language stream as well. But we'll see. We'll have to see about that.
We'll do our best.
Yeah, yeah.
Less memory does not matter at all. So it doesn't really matter how fast you solve the problem or how much memory you use, as long as you're under the limit.
Right, right.
So if the limit is 10 seconds, if you take 9.9 seconds or you take 0.1, it doesn't matter. You'll get
Right.
1 point for solving the problem, and your penalty points will be based purely on the amount of time and wrong answers it took you
Right.
to get it correct.
Right, and the reason that they do this is that these problems are hard. The algorithm itself is the hardest part, right? And so if you implement the correct algorithm, if you implement a wrong algorithm, the data is typically designed so that if you implement the wrong algorithm, it'll take super long. Like it'll take, a million squared will take like an hour to run at least, right?
Yeah.
If you have an n squared algorithm running on an input of size 1,000,000. But if you have a asymptotically fast algorithm, we're trying to be it's a little lenient, You can write it a little bit, a little bit faster, a little bit slower. And we're not trying to reward that too much because performance engineering, while it is pretty interesting in its own right, it's not really what we're testing here. We're really testing the problem solving here.
Yeah, what's important isn't that your code runs in 1/10 of a second or 100th of a second. It's important that your code scales up and
Right.
that your code works with, whether it works with 20 things, that's good.
Right.
But if you work at a company with super big data,
Right.
if you work somewhere where there's a lot of information you have to process, 20 things is probably not going to be enough, and that's not a very useful algorithm in some cases.
Right.
So you might need to handle 1,000,000 things, and
Right.
and the question is whether you can handle 1,000,000 things kind of at all,
Right.
or whether you can't.
Right. Right.
And that's why the asymptotic, relationship between the input size and the time that your code takes to run is so important.
Right, right, yeah. Yeah, so I'm seeing here that there are already more than 1,000 submissions during this contest. I think I saw earlier that about 1/3 of the submissions have been correct, which means that, teams have been working through the set. Teams have solved maybe like a couple problems each.
I also believe, though I'm not fully informed here,
Mhm.
that this practice contest is 2 hours long,
Right,
and we are approaching the 1 hour and 30-minute mark.
right,
What that means is, I think, the scoreboard is about to freeze.
right,
And we'll see what it'll look like during the last full hour
right,
of the 5-hour contest tomorrow.
right. So the scoreboard freeze, I believe, what we'll see when teams submit, right? We'll see when teams, we'll see teams submitting code, but we won't see the verdicts. So teams obviously will still see the verdicts of their own submissions. So they'll see whether they got it correct or not. But we will only see whether they submitted and not whether it was correct. And so this leaves a little bit of excitement and it leaves a little bit of uncertainty for the top teams. Like if you're trying to beat out another team barely, you actually don't know how much you have to solve.
Yeah, it's if like another team submits to a problem, you don't know whether they got it right or not.
Right.
So maybe you need 1 more problem to beat them, maybe you need 2 more.
Right.
And there are some interesting strategies that might happen with that. There was actually one time when I was doing a contest, and this wasn't like it wasn't like World Finals or Regionals or anything,
Mhm.
but it was a practice contest with other teams also from UCF.
Right.
And we were approaching the 4th hour, and we had a solution to one of our problems.
Right.
But the way the contest was set up, there were a lot of it was kind of like last year's NAC, where there were like several easy medium problems,
Right.
and then there was this gap, and the rest of the problems were all quite hard.
Right.
Now, all of lots of teams have solved all of the easy medium problems, but no one had solved any of the hard ones.
Right.
And we were at like 3 hours, 58 minutes was when we had figured out the answer. So what we chose to do is wait an extra 2 minutes,
Mhm.
take the extra 2 penalty points in case we got it right,
Right.
and then we submitted to that problem.
Right.
But in addition to submitting to that problem, we submitted wrong answers, just empty files, to all of the other problems, because we didn't want to give away which of the other problems we were working on.
Right.
So the rest of the teams would know, hey, this is the one of the hard problems that's actually solvable.
Right.
We intentionally got wrong answers on the rest of them.
Right.
And I thought that was a fun, interesting case where there was this kind of wacky strategy that involves intentionally getting things wrong.
Right, right. Because you don't even get penalty unless you actually solve them, right? And the
Exactly,
20
yeah.
minutes could totally be worth just like not revealing the information.
If it means one of the other 3 teams that has a possibility of beating us doesn't know which problem to go for,
Right.
then it could be the difference between us getting first and us getting second.
Right, right. And yeah. So I think scoreboard is now frozen. We can still see the stream of submissions coming in, but we will no longer see whether they were correct or not.
And we won't be getting any like top secret information that we have that you guys don't.
Yep.
So
Yeah.
we're as much in the dark as you.
Yeah, I don't know. I think they are even turning off our ability to see team webcams.
So we can't see whether they're celebrating.
So we can't see whether they're celebrating or not. I mean, sometimes teams even teams try and trick us and the teams around them though. So sometimes like I know that some teams, when in the last hour, when you get a problem correct or incorrect, like you celebrate the same amount.
I know one of the things that one of the fun facts from the last contest we commentated on, Andrew,
Right.
was MIT's fun fact, which was they spent time practicing pretending to get a problem wrong in the
Right.
last hour when they actually got it right.
Right.
And I think part of that was to convince all the other teams around them that their submission was wrong, when in
Right.
fact it was right, in order to have the other teams plan
Right.
incorrectly what they were doing.
Right. Yeah. Oh, we have some audio problems.
There's someone's talking quite close to the mic, it appears.
Okay.
I can't hear exactly what they're saying. Maybe the people on the stream can.
Right. But yeah, it's definitely pretty tricky, and there's a lot of pretty interesting strategy there. I think a lot of the time you should just focus on solving problems.
Yeah,
But
yeah.
when there are funny situations where it's worth it to try and outplay your opponents.
The peculiarity or the interesting uniqueness of those moments is what makes them so fun.
Right.
If they showed up all the time, it would just be
Right.
part of the game.
Part of the game. Yeah. Yeah.
Why submit wrong answers? If you don't submit at all until you have solved it, it still won't reveal anything. Not quite. So all of the other teams will be able to see which problems you submitted to and that you submitted, but they just won't be able to see whether you got it right or not.
Right.
So if we only submit to one problem, it's obvious we're working on that problem.
Right.
Or we're just trying to trick everyone.
Yeah.
We're just twiddling our thumbs, but actually we wanted to submit to a problem to make everyone think we're working.
Right.
Of course not.
Yeah. Yeah.
What do you think of Bangladesh so far, Andrew? Is this your first time here?
It is my first time here. It's been a pretty good trip. I haven't had too much time to explore or anything yet.
I think we've been in a very controlled environment. Most of this has been just this ICPC area,
Right.
and probably the hotel where we're mostly interacting with ICPC people.
Right.
But from what
there's been so much work to do here.
yeah, we talked about how there are these 6 studios. We set up all these we have 2 monitors here. We got webcams. We got lots of stuff. There's lots of stuff behind the scenes.
Yeah.
This was all done over the past 2 days.
Yeah, and it's not just us. It's been a whole team. And
there's a whole everyone's done an incredible amount of just structural building.
Right, and that's
here.
just the teams that we worked with this weekend.
Yeah, and
there have been so many different groups in ICPC organizing different pieces of it. The contest, the contest floor, the food, registration, opening, all of that.
we have been primarily in this building, which is Hall 4.
Right.
But as its name implies, there's also halls 1, 2, and 3.
Right.
And yeah, I haven't witnessed any of the work that's going on there.
Yeah. It's been a pretty massive.
I gotta say, my eyes were kind of opened to the crazy amount of work that's happened this year.
Right.
I've been to World Finals twice before as a contestant.
Right.
And I only just saw, I just saw the events that were happening, and I didn't see any of the effort that went into making them happen. But here, just this one bit, there's the amount of volunteer work that's put into this is mind-boggling.
Yeah, it's really amazing.
And this is only just a small slice of the pie. There's all sorts of stuff going on outside of this.
Yeah, but yeah, hopefully once this is all over, we'll have some time to go around Bangladesh.
Yeah,
Go around Dhaka.
It might be happening a couple days after the finals, maybe.
Right.
At least for those of us that don't have a super early flight.
Right. So yeah, we'll see how that goes.
The people here have been tremendously hospitable. I very much appreciate all of the kind things they say and do for us. It's very, very nice.
Yeah. It's been amazing.
Do you think a team will ever hold all their submissions until after the scoreboard freeze? I don't. I would be skeptical.
It's pretty tough to do that because of the penalty.
You get so much penalty.
Right.
For waiting 4 hours for every problem.
Right. And so you either you've got to be really confident that you're going to win on problems, or you're going to beat whoever you need to beat on problems rather than on penalty.
And if you don't, it looks really bad.
It's pretty bad, yeah.
Yeah. You'll be answering questions from people afterwards for sure.
Right.
So
Right. Holding some problems maybe sometimes is good, but usually it's probably not worth it. The scoreboard, especially since there are so many good teams here, right? Even one of the top teams, they're like whether they solved one particular problem actually doesn't matter too much, because the information about which problems are easy, like the other top team is going to submit it anyways, you know. So it's pretty tough to the scoreboard is really you can't game it too much when there are so many other good teams around.
up until the point where there's only like one or two teams solving the problems that are a certain difficulty,
Right.
you hiding things doesn't really matter.
Doesn't really matter. And so
Yeah.
it's just not worth it at the end.
Because the penalty you have to pay for taking longer to solve them is just
Right.
yeah. Not helpful.
But we'll see if anyone tries any crazy strategies.
It's fun, yeah. It
Yeah.
always makes things interesting, and it makes the scoreboard reveal after contest even more entertaining.
Right. Yeah.
So, we'll see.
Yeah, I think we also will get a test of the scoreboard reveal. I'm not 100% sure, so we'll have to check on
yeah,
that.
well, I'm not sure if it'll be public, but
But we will also try and see if we can get that. Yeah, that might not be public. These problems are all the same anyways, so
yeah.
duplicates.
All right, I'm gonna go get some water, Andrew. But you can solo
I
run
will
this from here
hold it
for a
down.
bit.
Hold down the fort. We might have to shuffle a little bit to deal with the door.
The other day, I walked out of this room, and my foot accidentally hit the power cord, which controls the entire power system for everything here, all on one extension cord.
You think we should tape it down?
That would be a good idea. We should do that for tomorrow.
All right.
Goodbye.
All right. So, yeah, it's been the contest looks like it is kind of calming down a little bit. Still have teams around. I think we still have coaches around too. But teams are hopefully getting finished, setting up, testing whatever they wanted to test, setting up things that they wanted to set up. And yeah. One interesting thing is that they have to stop handing out balloons in the last half hour as well. So we don't even get to see new balloons. You only get the balloons for the problems that you solved before. You want to come in?
Yeah.
Hey.
Headphones?
There are no headphones for you,
That's alright.
but there is also not much going on in the background, so you should be good. Can you close the door?
Nice.
Yeah, when we close the door, the fan gets way louder, but
I see.
that's the price we have to pay for the noise isolation.
Got it.
So this is Nick Wu. Do you want
Hello.
to say something?
Yeah, hi everyone, I'm Nick. I'm known as Xiao Cone on all the platforms.
Right.
I'm here as an analyst, so if you were wondering who was sending in all those pictures of like submissions and whatnot, that was actually almost all me. I
Right.
was the one looking at the submissions, being like, what are we gonna figure out?
So were you actually fixing the bugs? Were those diffs between their consecutive submissions, or were you fixing some of those bugs yourself?
There were too many submissions coming in. The problems are so easy that, there are just tons of submissions coming in, and teams are, the problems are kind of easy, so the teams are able to debug on their own. So we were just copying and pasting like the diffs, like, oh, this team solved the problem and, they forgot their debug output, or they like didn't remove their debug output or whatever.
Right. Do you know if a lot of teams have the same templates or anything? Were you guys able to look at that? I saw some submissions from that.
Yeah, so a lot of teams will have like the same sorts of like imports. So a common like C++ import is like the bits bits std c++.h. And then I think there are some teams that straight up use like the kth cactal GitHub template that is like out there, and then they like make slight modifications.
Right.
Some teams just don't have a template at all. They just type the bits thing and that's it, and they're done.
Right. And were there a lot of? Do you know what programming languages people have been using? We were talking about this a little bit, but we weren't able to remember whether there were like 5 or more.
Yeah, the distribution is like the vast majority C++. Like C++ is like sort of the de facto standard. Like if you're like really serious about it, like you want to be doing it in C++. We did see a little bit of Java. We didn't see any C, and I think we saw a little bit of Kotlin and Python, I think, but like I don't know if those attempts are actually serious. But like by like looking at the language stats, it's almost all C++.
Right. Yeah, have you seen people testing big num libraries and things like that?
I haven't seen Big Num, but like I saw Warsaw testing int 128. So they were doing int 128 testing. Warsaw was doing tons of testing. So like if you look at the scoreboard, they have like 40 wrong submissions on A, and it's because they're testing like everything. They're testing like RAND to see that the seeded RAND on local matches like what's on the judge.
Right.
They like I sent in the screenshot of them testing policy-based data structures and
Right.
just like a bunch of stuff that they were just testing, looking for like any inconsistencies they could find.
Right. Testing seeded RAND is pretty interesting. I've never thought of testing that.
Yeah, I haven't either, and like it's interesting because they tested seeded RAND, but I don't think they I don't know that they tested like Mersenne, like the MT19937.
Right.
Like I did not see that submission, but they had 40 of them, so it was hard to look at all of them.
Right. Yeah. They probably maybe they just trust MT, but the being able to know exactly that the same code will run on the two machines is pretty valuable.
Yeah.
Do you know if the judge machines are actually the same as the contestant machines?
I think that they are exactly the same, although I don't actually know like the specific specifications. Like they didn't release that to us, but they try very hard to make sure that like what the contestants have is exactly the same as what the judges have. So if you run for like up to like 6 seconds, you'll make exactly the same progress on both. So it's consistent.
I see. Yeah. That's pretty useful for the contestants to be able to just know exactly it's exactly the same.
Yeah, for sure. Like you want to make sure that like you have like an environment that's like clean and
yeah.
Yep. I'm gonna.
You gotta make sure you keep this close to your mouth.
Oh, okay. Sorry. Am I
still not loud enough?
Should I be talking closer?
Are you listening to it, Andrew?
I need to just understand how loud it should be.
All right.
It's a good thing. It's maybe like I actually was asking like, are we gonna test like having a guest in or not? Because like if I should be like super close or whatever.
Oh, yeah,
like...
you should be closer.
Okay.
Yeah, I didn't realize.
All right. I'll
yeah.
stick this. I'll try to be like right in front of it.
Yeah. Are there any other teams that you saw today that were pretty notable?
I wasn't looking too closely at any specific team because we on the analytics side we're trying to test all our systems. So like we're testing the whole like how do you get the image to actually show on the screen and so on, and we want to communicate like we on analytics are communicating information to y'all on the stream so that you can see like the ticker at the bottom, for example. Like we in analytics are actually writing the messages that you see there. So we're really focused on all of that, and like I haven't really been paying attention to like oh, this top team is like present or not present. At some point in the middle I was like, oh, I want to highlight all the local teams from Bangladesh. So I brought in a random screenshot from our host, University of Asia Pacific. Then there's Bangladesh University of Engineering and Technology. I think the other local universities don't have any submissions, so I can't really share anything because I don't have anything.
Right. Maybe
you just ignore me.
Okay. Yeah. Yeah, makes sense.
Yeah. Whoops. But yeah, so yeah, I haven't been paying attention to like the like super top teams, but like National Taiwan University is a strong team. Seoul National, Swarthmore, Oxford. I forget who else was there. At some point, I got pulled into looking at other things, so I wasn't monitoring the scoreboard. But like cool. I need to be better about this. But like Warsaw is like a strong contender, but they're not actually trying to like win the dress rehearsal. They're like testing everything.
Right. Yeah, I mean, arguably the Warsaw kind of probably got the most out of any team out of this dress rehearsal.
Yeah.
They really have the most information that would actually help them, help them compete on the actual stage.
Yeah, for sure. Like, you have a lot of like these open questions because when you're practicing, you're in like in like your comfortable, pristine environment, and you're used to a bunch of things. But here, everyone is competing on a level playing field, so everything is a little different. So the keyboard is a little bit different, the mouse is, the monitor, and
Right.
you know, there's just so much that you want to like configure and mess around with, and comfort can matter. Like it's all these little things can just like add up. And so, you know, teams do want to make sure that they're like comfortable. They know like this is the tooling and it works properly. So Warsaw is definitely taking the approach of like they're trying to stress test everything. They want to make sure that they're prepared for you know, if they need to pull out policy-based data structures, for example, they now know like, oh, it looks like it works, versus like, you know, maybe if it didn't work, they would have like a contingency plan that they figure out like tonight. In preparation.
Yeah. Maybe they would have to, you know, put something. They can't edit their book anymore, but they could, you know, maybe learn something new, learn some alternative, or look things up like that.
Exactly. Like it's the sort of thing where, you know, it probably doesn't matter. Like, I mean, none of us know the problem set, so you know, we have no clue. Like policy-based data structures, I don't think have been essential for any World Finals problem yet.
Probably not. Yeah.
But you know, first time for everything.
Right. And I mean, if you've got 2 hours to submit code, you might as well submit some code.
Yeah, like, you know, for some teams, some teams are probably using the dress rehearsal as literally like we're going to warm up. We're going to try to solve these problems. Like, maybe some of these teams probably don't know that these problems are old World Finals problems. They might not have ever seen them, and so they might be, you know, actually solving them.
Right, and I mean, warm up is good too, right? Some of these teams might not have practiced in a long time, right? This is actually, it's actually been a long time since these teams qualified to the World Finals, right?
Yeah, it's been like, at least for like the North American teams, it's been like a year and a half, and we hear stories all the time about how these contestants, like, they graduated and now they're full-time employees at companies, and they don't have time to practice because, you know, you're working a job and you have not nearly as much time as you did when you were a student.
Right.
So,
but yeah, these teams still have all made it out to here to compete, and that's pretty exciting.
Yeah, it's good to see that, you know, even though like these folks are you know, going back to or like leading lives like outside of university, like they're still coming back into ICPC and they're actually doing this competition. That's really nice to see. Yeah,
it's pretty exciting. So are you guys controlling which screens are shown on the out of these 4 live streams?
So there's a little bit of synchronization that happens between the ICPC live team, the team that's putting on this broadcast, and then analytics. So we on analytics, we have there are like 3 things that we can do. So as mentioned, we control the ticker at the bottom with the text. We're currently debugging it. We were seeing some issues earlier today. We have the ability to theoretically highlight like important submissions. So in the bottom left, you see like this queue of all the submissions coming in.
Right.
And so there might be like a critical submission. Like say the rank 2 team comes in with a submission, like we would like highlight it and be like, you know, if this team solves this problem, they go from 2nd to 1st, and you know, now they're winning if they get it right, for example. Like that's like that would be like something that a lot of people would be curious to see. Like, does the rank 2 team like jump into 1st place?
Right.
And then the 3rd thing is like the little like images that were coming through. So like I was sending in like these screenshots of code snippets, diffs, whatever. So analytics, everyone on analytics has the ability to send in those pictures. But that's where we need to do a little bit of coordination with the live team. And so like here you can see that the live team is the one with the screenshot.
Stop being so serious.
Okay, goodbye.
Damn.
Wow, okay, no more serious. Okay, only funny.
Oh man. Funny. Should I hop out?
Lydia's worried about the quality of our stream being too high and us having to replicate it in our future World Finals tests.
What the?
Our future World Finals tests?
I don't know.
Okay. I mean,
do you want me to hop out? Should I hop out?
Practice juggling, make a little silly for
Oh my god. I don't know how to juggle. What are you talking about?
Is juggling lower quality? I don't know. They might expect real entertainment going forward.
We shouldn't be trying to promise real entertainment here. Like, you know, some of these people actually want to learn stuff.
We could just be total clowns.
Hey, I mean,
we can just leave.
I do. Just leave it on.
You should have told me.
Is that what Lydia wants us to do?
You should have told me that we wanted like entertainment. I have a clown nose. I brought my clown nose from home, but
Andrew, do you need lunch or anything?
Yeah, I'll grab some.
you should grab lunch. I already ate. Should we? How do we shuffle? Huh?
I want that seat, so I have the.
You want this seat?
Yeah.
Yep, sounds good.
And then I have
Let me.
we gotta do the door thing.
The quadratic time swapping 3 people. Oh my god, quality too high. Sorry, I'm about to knock out our commentators.
You're good. You're good.
All right, how's your water?
My water break was great. I had some food. We got some great Snickers bars just for staff over here.
Did you know that
Delicious.
at one of my during one of my internships, like they just called me Snickers. It's because Nick is a substring of Snickers, and for whatever reason, it just like caught on, and I'm like, and now there are people who like still call me Snickers, like 6 years later, and I'm like, I don't respond to
That's
this
a top
anymore.
tier name. Snickers. I like it. It's good.
Maybe
That's solid.
is that Coach Force's handle taken? We should maybe I'll change it.
We can check real quick.
Oh man.
Let's see.
In a different in one of my Discord servers, we follow League of Legends. Oh, Snickers is taken.
It's taken, but they haven't done any contests.
So I could replace it.
You might
with
be
the
able
whole
to
thing.
steal it during Code Force's Magic.
Yeah, I was just remarking. So, you know, everyone looks at my handle and so it ends with like C and then the digit 1, and when most people type it out, they omit the 1. But like when I pronounce it, it's pronounced cone, because
Wait, so what is your handle?
so it's XIAOWUC and then the digit 1. But I
Like
pronounce
that
it.
last part of it is cone?
Yeah, so the last part is cone because it's C and then 1 is actually cone.
Gotcha.
And so for the longest time, like in a lot of Discord servers that I'm in, like I would actually like spell out 1, so then it's like cone, and then people were like, "That's not your handle," and I'm like, "Just look at it." And then in a different Discord server where we discuss League of Legends, so I'm cheering for a League of Legends team called T1, and so I changed my handle from Xiaowu C1 to Xiaowu T1. And then everyone's like, "Oh, so you're now Xiaowu Tone," and I'm like,
They got it wrong on both accounts.
"Oh, I'm so sad."
All right, so on a more serious note,
Oh no.
to unfortunately increase the quality of our stream again, I'm going to mention this. Have you read this set of problems yet?
I read the set of problems like multiple years ago because you know they're all. They're
Let's
old.
go through them once more here. Here's
Oh,
what we
no.
got. We've got problem A, catering. Now,
Yes.
not to spoil this for anyone, but this is a flow problem.
Yes.
Min cost max flow, I think.
Yep.
Problem B, comic sprinkler. This is just a banger problem. This is very easy. Sorry.
It's a really cool
easy
problem. It's a really cool problem.
I don't think it's that cool, but it's easy. So there's kind of an inside joke going on here. We were talking about what a banger problem is, and my friend group always thought that meant the problem was really easy, but of course the rest of like the continental United States calls
Like
something a banger if it's
yeah.
a good song, right?
Yeah, like songs are bangers. Like you don't like there's no notion of difficulty for songs. You're like, oh, this song's a banger. Like I really want to listen to it. So when you say a problem's a banger, I'm like, okay, I really should like look at this.
Yeah,
But
it's like
that
a
just
really
makes it
good
easy.
problem. Yeah, that's I don't know. I guess that's just what I mean when I said maybe over time the definition will evolve. Okay, that's problem B. Problem C is go with the flow. It's a very implementation heavy, annoying to code problem, and you just have to do some things carefully, but it's not really that hard. It was again from Beijing. Problem D is landscape generator, which we already talked about. It starts with interactive creative players collective, but it's not actually an interactive problem. 4 minutes left in the contest, says people.
Right.
And last one is problem E, which is pollution solution, which is a problem about
It's a geometry problem.
yeah, it's a geometry circle polygon intersection problem.
Yeah, it's from 2013. That was the second year I went to World Finals, and I had one of my teammates be like, "Oh, this is how you do the problem," and then they made me code it because they were like, "I don't want to type geo," and so they made me type the geo.
But here's the thing. I've just gone through all of the problems. That's it. That's all the problems. What have you noticed isn't here? In any of them?
I don't know.
An interactive problem. There are no practice interactive problems.
You know what that means?
Does that tell us there are no interactive problems in the final set?
No,
Is that a promise?
I think the judges are going to promise that we're going to be anywhere from 0 to all of the problems are interactive problems.
But that's like a very odd decision to not have any interactive problems in the practice set. If they're there in the finals, isn't it?
I'm sure that like in some dress rehearsal somewhere they like did the same thing and they were like, teams will expect that there were no interactive problems. There's no way that in the finals they would, prepare an interactive problem, right?
I mean, I could see it happening, but I don't know. I feel like this is just. I feel like if I were the chief judge, one of the things I would say is make sure there's an interactive problem in the set. I mean, I know, to be fair, we had an interactive problem in last World Finals, so they're known to be allowed. It's known they're a possibility. But I don't know. I feel like this might be some information. I haven't talked to this. I haven't seen the problem set. I don't know anything about it, but it's just me, my hot takes. What does chat think? What do you guys think? Is this a promise that there will be no interactive problems?
That would be an interesting information leak. But if you look at this set carefully, you look at it and you're like, oh, like FFT doesn't appear in the set. Like linear algebra doesn't appear in the set. Is that a promise that there won't be an FFT problem or
no
a
math
linear algebra problem? Yeah, like it'd be great if the dress rehearsal were like this, but
it's true. The only reason I think interactive problems might be a little different is because it's like a thing to test. There's it requires like a different type of input.
Yeah, that is true. Like it is probably like we're all speculating here because none of us are talking to the judges. None of us have seen the judges. They're sequestered away somewhere. So we're completely speculating here. But if there was an interactive problem, it would probably be good to test that sort of thing in the dress rehearsal. Like when we say dress rehearsal, it's not just for the contestants. It's for literally everyone. Like the contestants are obviously practicing on a problem set. The judges are practicing all their configurations. The people doing food are rehearsing the food thing. They were stressed out about food as I was walking around and they were
it's a big ordeal. Yeah, getting people food. It's tough. With this many people, it's what 136 teams. That's over 300 people. It's a lot of people.
There's it's almost 1,000 people I bet that they're trying to feed all in the ICCB, and they're also split up. A bunch of us are in hall 4, the contest venue, but then you have staff in the other halls. You have the chill zone in hall 2, and the sponsors who have their groups there, and they're also getting fed and stuff. So.
We officially have 9 seconds left in contest. Here's the countdown.
5.
Wait.
Oh.
There's a pause here. Going off from here. You can't. Oh, sorry.
That's okay. I could kind of hear it for your headphones.
Yeah. All right, there you go. That is the practice contest. They will probably announce. Oh, okay. I'll let you listen to what's happening here.
This is for everybody about your departure details. So we'll be sending out an email explaining to you what you need to do for departures. Also, we've changed the location for bus loading to ease some of the congestion. It's now at the expo zone behind Hall 2. The bus loading is at the expo zone behind Hall 2. You can enter by walking down the path between the white tents and Hall 2, and there will be some host volunteers there to guide you. So all this is about getting home. Getting home tonight is the new loading zone in the expo zone behind Hall 2, and then make sure you're looking out for an email giving you instructions on your departure.
All right, so yeah, that is the practice contest. We'll be doing, or it probably won't be streamed, but there will be answers to the questions asked and clarification requests during the practice contest, and then we'll have the real contest tomorrow. Guest visitor?
Can I break your things?
Break our things?
Yeah, I want to open Figma, fix the web
Our
communication
coaches.
stuff.
So
Yeah,
at
go
this
ahead.
time,
Do you want to do it live?
I'd like to honor
I
this
don't
year's
care.
recipients of the
Will it look
ICPC
super
Coach
professional?
Award.
No? Then yes, I want to do
It's
that.
because
Don't you
of these
all about
coaches'
low
dedication,
balls?
Okay, so I'm removing the studio mode and I'm
hard work,
adjusting
and
that
personal
manually now, right?
sacrifice
Alright,
Okay,
that all of you
whatever.
students are here today.
How many people does
we're
it take
here
to put on an
celebrating
ICPC
you.
broadcast? The answer is
Coach awards
just
are
one.
given
One?
to coaches who have
No,
been
literally,
teams
literally.
together
No, hold on, hold on, no. That's not
for
like
5 years or more.
by design.
Senior
We
coach
want to build
awards are
ICPC
presented to
Live in
coaches
such a manner
who
that you
have
can
brought
actually
teams to the
run
World
it
Finals.
solo. We have
50
automated
or more
mode,
years. That's
so
a lot
all
of
these,
years
these,
coming to a World Finals.
okay.
And lifetime
So,
coach awards are for those
and the coach
coaches
award is actually an
who have
official
brought teams
broadcast,
to the
right?
World
Thank you.
Finals 20 years or more. So let's get started. Our first presentation, and I want a big round of applause for our Lifetime Coach Award recipient. This is a coach that has been advancing teams to the World Finals for 20 years or more. It is with great pleasure to present this Lifetime Coach Award for Excellence in Coaching to Belarusian State University, Vladimir Kotov. Vladimir. All right. Thank you, Coach Kotov, for your contribution to your team for over 20 years. Now I'm going to ask you to stay up here because I would like for you to accept our next award on behalf of Coach Alexei Tolsikov. Coach Tolsikov is receiving the Coach Award for Excellence in Coaching, having advanced teams to the ICPC World Finals for 5 years. Congratulations, Coach. Thank you. Congratulations. All right. Our next award is given for excellence in coaching, having advanced teams to the ICPC World Finals for 5 years. Please congratulate and welcome to the stage in Instant Technology Roorkee, Balsubraman Raman. All right. Where's our? Are we looking at you or Bob? Oh, you want us to look at you because this web. Congratulations, folks. Thanks so much for your hard work. All right, and continuing with our 5-year recognition, please congratulate and welcome to the stage 5-year coach recipient from University of Michigan, Denis Denis Matveev. I'm gonna fix that. Matveev. All right, which? Face this way. Congratulations, Coach. Our next 5-year Coach Award for Excellence recipient is from University of Campinas. Please join me in congratulating and welcoming to the stage Fabio Usberti. Fabio. Congratulations. Thank you. All right. Congratulations, Coach. Our next Coach Award for Excellence in Coaching, having advanced teams to the ICPC World Finals for 5 years, from ITESM Campus Monterrey, Coach Luis Humberto Gonzalez Guerra. All right, we're going to check that over here. Oh, here we go. Our 5-year Coach Awards continue. Please welcome and congratulate for excellence in coaching to the University of Bucharest, Coach Marius Dumitran. Marius. Congratulations, Coach. Our final Coach Award is being presented to a coach that has been advancing teams to the ICPC World Finals for the last 6 years. Please congratulate with me from Beijing Jiaotong University, Qingyang Li. Unfortunately, the coach could not be here, so let's have the team from Beijing Jiaotong University come up and accept on his behalf. Beijing Jiaotong. Congratulations. Why don't you go stand right there? Congratulations. All right. Thank you. All right. The middle of your hold, we're going to aim ourselves right over there. All right. Congratulations, Coach from Beijing Jiaotong. Hopefully I'll be on stage with you guys at the closing ceremony. That would be exciting. All right. So next, I would like to welcome back to the stage Dr. John Clevenger. All right, some of you may have noticed that I am not Dr. John Clevenger. Don't think that I'm stalling for time, because that's absolutely not what I'm doing, is stalling for time. All right, just a second, and we'll get our A to Q started. Thank you. All right, you guys must have asked some great questions during the practice contest because we're still working on our answers for the A to Q. So take a few minutes, relax. If you need to go to the restrooms, they're here on the side. And in about 15 minutes, we'll get up and do our A to Q and answer some of your hard questions. Thank you.
Bye.
Okay, we are finally ready to go. So if I can ask everybody to have a seat, please. You're ready also? Okay. I'll go through mine and then I'll introduce you. Okay, we have a number of questions, and in order to be fair to everyone, I would like to ask everyone to have a seat and listen quietly, please, so that people who ask the questions can hear the answers. Okay, we're sorry it took so long to do this, but we got a lot of questions asked, and we wanted to make sure that we responded properly. A lot of the questions that we asked have answers, documentation that has been provided on the ICPC website since July. And so if we do not answer a question you asked, you should interpret that to mean the answer is in the documentation. You can go back to rooms tonight. I know you all have connectivity. You can find the answers in the documentation that's on the ICPC website or in your technical notes. But there were a few questions that were not on the website, so we'll answer those. There were a number of questions about food. Frankly, we know there was an issue with getting the right lunches coordinated when we've got 100 people and volunteer staff doing their best. It was a bit of a problem. We will try to do our better tomorrow to make sure that everybody gets the lunch that they asked for. Calculators. It was asked, will we have calculators tomorrow? There will be a physical calculator provided on each team workstation tomorrow. So you'll have a calculator. We're aware that some people find it uncomfortably cool in here. Also people who still find it uncomfortably warm. So we're trying to strike a balance with the temperature desires of about 300 different people. We will do the best. I will just remind you that the rule is you must wear a ICPC shirt on the outside tomorrow. If you think you're going to be cold tomorrow and you would like to improve your temperature, if you want to be warmer, you can wear a long sleeves or a jacket, a sweatshirt underneath the ICPC t-shirt. We will do our best to try and get the temperature balanced. A number of questions were asked about getting balloons delivered. One of the reasons we have a dress rehearsal is to iron out the kinks, and so that we won't have the same problems during the actual World Finals tomorrow. We will do our best to get balloons delivered tomorrow as rapidly as possible. We found a few kinks in the system and we will try to work them out. Question was asked about pencil sharpeners. We don't have pencil sharpeners, but we will try and get extra pencils. If you need an extra pencil tomorrow, you can raise your hand and ask a staff member, and we will do our best to provide you with an additional pencil. Question was asked about are we freely allowed to leave our workstation and go to the restroom? Yes, please. We would prefer that you do that. Yes, during the contest, contestants may leave and go to the contestant restrooms. There are no spectators or coaches allowed in these restrooms, and contestants may not leave the contest floor, but the restrooms are part of the contest floor. You can go use the restroom once the contest starts tomorrow. There was a question, can we change our lunch order for tomorrow? We have no way to support that right now, because if we start that, we'll be having 300 changes. Let's see. There were a number of questions asked about the problem set that you used in the dress rehearsal contest. This was a practice contest to make sure things are going to work. We're not going to spend time answering questions about, like, what are the locations in the problem tomorrow. If the problems tomorrow are going to be different. The questions you had about the particular problem set today are essentially moot for today. The question was asked, is there a digital copy of your team reference document on the contest computer? The answer to that has been posted on the ICPC website for months. The answer is no. There were a number of questions such as, what possible verdicts come back from the judges? Does a compilation error cost a penalty? What is the penalty for a wrong answer, and so forth? All of those kinds of questions are answered in the World Finals documentation that has been on the ICPC website for months, and it's still there. A question was asked about the sample files for the problems. The sample files are in the SAMPS folder, but it's not in your home directory, it's under your desktop directory. So if you were looking for the sample files and couldn't find them, look in the desktop folder, and underneath that there's a SAMPS folder. There were some questions asked about Kotlin, the version of Kotlin versus what is installed inside the IntelliJ IDE. Yes, we're aware, if you're using Kotlin, the version of Kotlin that's inside the IDE is not exactly the same as the one that's used on the command line. We will try and get that fixed before tomorrow. A question was asked about keyboards. For example, can we bring our own keyboard? Is there an ISO keyboard available, etc., etc.? It has said on the ICPC website for months, here's the keyboard that's going to be used. Here's 2 different pictures of the keyboard that's going to be used, and teams may not substitute their own keyboards. Everyone uses the same keyboard in this contest. There was a question asked about extensions for the Visual Studio Code installation. Yeah, we're not sure exactly what the issue is, but we will try to fix it tomorrow. There apparently are plugins and extensions that are not as we expected them, and we will try to fix that. Question was asked, can you take the printouts, the things that you printed out today, back to the hotel with you? Yes, you may do that. What you may not take with you is your team reference document. That must stay here because you won't be allowed to bring it back in tomorrow. Actually, I'll correct myself. You may take it with you, but you won't be allowed to bring it back in tomorrow. Leave your team reference document, leave the pencils and papers and so forth on the desk. But you can take your printouts that you made today. There is also a minor discrepancy between the Python documentation that's on your machine and the version of Python that runs. The version of Python that runs when you submit a Python program is, as it has said on the ICPC website for months, 3.7.2. the documentation that says it's Python 3.8 is in error. We will try and fix the documentation. There was a question about something about what happens when we click the mouse wheel, and can we disable the mouse wheel click, and how do we do that? And the answer is, go look in the Ubuntu documentation. You have until tomorrow morning to do that. A question was asked about using Xmod map to change keyboard mappings, and someone said it doesn't work the same way as it did yesterday. We didn't make any changes. We re-imaged your machine last night and put it back to the same image as it was when you started, so we have no idea why the command that you typed yesterday doesn't work today, but I would take a guess as to why, and that would be keyboard error. And that's all the questions from an operational and a technical point of view. There are also a number of technical questions about the judging process, and in order to deal with those, I'm going to introduce Toby Worth, who is the World Finals Director of Contest Control Systems and one of the primary authors of DOM Judge. Toby?
Thanks, John. Okay, we had a nice test today, I hope, but there's still some questions left to answer. Be aware that when submitting multiple attempts in a short amount of time, your submissions will be down prioritized by our scheduling algorithm, and you may receive your results later than other teams that have submitted later than you. So you will be punished a little bit by this. That's your choice, I guess. Judging for your team will be slowed down. We appreciate that you did some testing, some stress testing during the stress rehearsal. I mean, that's what it is for. But for tomorrow, consider that anything that might be detrimental to the execution of the contest is not allowed. So submitting 200 times in a row in 1 minute may not be a good idea tomorrow. The hardware that we use to evaluate your submissions is identical to your team machines. We use the same operating system, we use the same base image. We just tuned it a little bit to make timings more consistent on our side. For example, we pin your submission to a single core. You don't do this for yourself here on your team machines. Today, there were some team machines that were not configured correctly. They were run faster than the judge hosts. That will not happen tomorrow, and we already fixed that. So if you practice in the open practice session, that should be fixed. We will run your submissions on all the test cases that are available in a deterministic order. That means if your program is incorrect and on one test case it gives wrong answer and on another test case it gives run error, we will report the verdict on the first test case that is in this deterministic order. So if you will submit this program multiple times, you will always get wrong answer, even if at the later test case you also have a run error. There is no specific memory limit verdict. Of course, we limit your submissions to the global sandbox limit of 2 gigabytes. It will be reported as run error as a verdict. The stack size limits are as follows. For C and C++, we have unlimited stack size within the sandbox limit of 2 gigabytes. For Java and Kotlin, we have 64 megabytes. And for Python, we didn't change the default. And one final question about the online judge that the coaches can compete in. No, this is not using the same hardware So we don't give any performance guarantees. If the submission will work there or here, that's not equivalent. No guarantees given there. Thank you.
Okay, at this time, we move into what's called open practice session. We are going to re-enable your machines. You have between now and 3:30 to do whatever you want on your machines. If you want to go check to see if some of the responses to the answers to questions we've got, how that works, you can use your machines to do whatever you want. If you are done and you don't want to spend any more time in here, you are welcome to go back over to Hall 3. The buses are starting soon to go back to the hotel. Make sure you leave your team reference document here. And you have until 3:30 available. The machines are available. Once again, a final reminder, please make sure tomorrow morning that you allow extra time to get to your elevator in your hotel, to get down the elevator, and to get on your bus, because your bus is going to leave, and we would hate to leave anybody behind, but we will. Thank you all, and we will see you tomorrow. If you left anything in Hall 3 when you came over here in the processional, you should be sure to go back to Hall 3 and pick it up. Okay, it will be there for a little while, but I don't know how long a little while is. So all of that material is available in Hall 3. One difference between the dress rehearsal and the open practice is we're not delivering printouts. Don't try and print anything, you're not going to get it.